last session that when we set up an AWS account, so in every region, AWS basically provisions a VPC for us, which basically we are calling it as a default VPC. And the characteristics of a default VPC is,
I'm sorry?
the characteristic of a default VPC is like it will be having subnets. Subnets will be equal to the number of availability zones. Number of availability zones in that region. Okay, let's say this region, this Osaka has 3 availability zones. So if we go to subnet, so here we have 3 subnets, and each of these subnets are in a unique, in a unique availability zone. Let's say 3A, 3B, 3C, right? Okay, it has one route table. It has one internet gateway, right? And it has a NACL. Okay, NACL is network access control list. Okay. And all the subnets are basically later. Basically we'll be calling all these subnets as public subnet. Okay, all are public subnets in the default VPC. All are public subnets. What are public subnets? In public subnet, basically, we can like the resources which we launch in a public subnet are accessible over the internet. Okay, and if we talk more technically, so the subnets which have a route to the internet gateway are called public subnets. Okay, the subnets which have route to the internet gateway. Later we will see like how this routing and all things are working. So that time it will be much more clear. Okay, then we have CIDR. So of a VPC, the default VPC, CIDR of all the default VPCs are same. Okay, what is the CIDR? CIDR is just a network range. Okay, this is the CIDR. Okay, and this CIDR is for all the VPCs, all the default VPCs. Okay, so this can be asked in the certification exam, like what is the CIDR range of the default VPC? Okay.
So
How many subnets? Sorry.
it doesn't matter what region it's in or anything. That's always going to be the default CIDR range.
Yeah, exactly. Yeah.
Okay.
Not default. It is on the default VPC. It is this one is the CIDR range on default VPC of all the regions.
Okay.
And in the certification exams, in the certification, they can also ask like how many subnets we have in the default VPC. Okay, so there you will find an option which says the number of subnets in the default VPC depends on the number of availability zones in a specific region. Let's say Virginia has 6 availability zones. So in the default VPC of Virginia, there will be 6 subnets. Okay, and to identify the default VPC, we can identify it by the CIDR range. Another way is, if you go to details, you'll be able to see one option which says default VPC is set to yes, which means this is the default VPC. Let's say if you have created some custom VPC, so you'll see no. Okay, so this is the default VPC which is created by AWS and having this CIDR range. Okay, now we will see the subnets. So this is Virginia. and Virginia has 6 availability zones. Okay, and here we can see 6 subnets, and each of these subnets are in one availability zone. US East 1A, US East 1B, 1C, 1E, 1D, 1F. Okay, here we have 6 subnets, and the reason is that in this region we have 6 availability zones, and hence we have 6 subnets. Okay, this is basically a characteristic of the default VPC. Okay, the subnets are equivalent to the number of availability zones in the region. Okay, do you have any questions still here?
No, go ahead.
Okay, now we'll be talking about custom VPC. Okay, custom VPC is all about like creating our own VPC. Okay, now first let us talk about what is the need of creating our own VPC, or what is the need of creating a custom VPC. If AWS is providing us a VPC, and which VPC, and this VPC only basically we use, so far we use this VPC only to launch our EC2 instance, to launch our RDS database. Okay, so then what is the need of creating a custom VPC? Okay, now it creating a custom VPC completely depends upon what kind of application you want to deploy on AWS. Okay, now let's say you want to deploy a two-tier application. Okay, a two-tier application which has a front end and which has a back end. Okay, front end is basically accessed by the users over the internet, and back end is something where you are running your database. Okay, your database or storing some data. Okay, which you don't want to be accessible by the users over the internet. Okay, uh, which you want to be secured, right? So currently in the default VPC, if we see the architecture of default VPC, so let's say this is a region, and inside the region we have the default VPC. So let's say this is Ohio region, or let's say Osaka. Okay, this is Osaka region, because we are going to work in this region, Osaka, and the name of this region is the region code is AP Northeast 3. Okay, and in this region we have 3 availability zones, right? So this is availability zone 1, 2, and 3. Okay, so the outer layer is of region. Inside this we have 3 availability zones, and inside this is the VPC. Okay, and inside the VPC we have 3 availability zones which are at the region level, and here basically, yeah, we can name them like AP South Northeast A. This is the first availability zone. This is the second availability zone, and this is the third availability zones. And in each of these availability zones, let us name this as default VPC. Okay, and in each of these availability zone, as in default VPC, we have one subnet in each of the availability zone. Now, the reason of having subnet in each of the availability zone is for high availability of the network. Okay, let's say we create all the subnets in only one availability zone, and let's say if this availability zone gets down, so there will be a network failure. And if there would be a network failure, your compute nodes, your database will also get down. Okay, because compute nodes, databases, everything are running on network. Okay, under the on top of the network. Okay, and if the network is down, all the resources are down. Okay, even if your server is running, but if it is not in the network, then it will not be accessible to the internet, right? So that is the reason we create one subnet in all the availability zones. Okay, or AWS is also created in the default VPC. They have created one subnet in each of the availability zone. Okay, subnet we can just assume as a switch. Okay, like like using a switch, multiple computers are connected, right? Let's say at our home we have a Wi-Fi, and through our Wi-Fi, basically our phone is connected, our laptop is connected, our desktop is connected, right? So same way we have a subnet. Subnet is just we can assume as a router. Router, or we can assume it as a switch, which is basically connecting multiple devices. So in this in the subnet, we launch our EC2 instances. Okay, in the subnet, our EC2 instances are running. Now let's say in this region, in this availability zone, if we don't have a subnet, so we cannot launch a EC2 instance. Okay, if the availability zone doesn't have a subnet, then we cannot deploy resources in that availability zone. Okay, let's say if we don't have a subnet in AP North East 3C, then we'll not be able to deploy EC2 instances or RDS database, or any resource which deals with network will not be able to provision in that specific availability zone. Okay, so if you want to create resources, so we need the subnet in that specific availability zone. Okay. Okay, so we have subnet, then we have route table. Okay, VPC, as we discussed, VPC is more like a router, right? And inside router, we have routing table, right?
Mm-hmm.
Inside router, we have routing tables. Okay, and routing table basically defines which network will be talking with which network, right? So here in AWS, we have the concept, we have the same concept. Here we are calling it as route table. Okay, we are calling it as route table. And in this route table, basically we create routes. Okay, in route table we create routes. We see router routing table. Yeah, this is how basically it looks like. Okay, yeah, here basically we are basically doing mapping, like which network will be able to talk with which network. Yeah, something like this. So the same route table, routing table we have in AWS by the name of route table, and this also basically we create routes. Okay, here basically we define which network will be able to talk with which network. So when we created VPC, I mean in the default VPC we have one route table, and all the subnets are associated with this route table. Okay, when we create a route table, so in that route table we have to associate the subnets. Okay, we need to add the subnets inside the route table, and all the rules which are written in this route table are applied on those subnets. Okay, so in a route table basically we have to do two things. One is subnet association. Okay, subnet association is nothing but assigning subnet to a route table. Okay, and once the subnets are associated with a route table, then basically we create rules, or which we can call, in AWS we call it as routes. Okay, and route basically we tell like which network will be able to talk with which network. Like in that, basically we have route like this. Like this network will be able to talk with a different network. It's like this. These kind of rules we have. Okay, and this is basically telling us like these are two different networks. And in the routing table, basically, if we create a rule like this, so it basically is showing that this network will be able to talk to this network. And what is this network? This is the CIDR range of the subnet. Okay, VPC has a CIDR range, or each of the subnets have their own CIDR range, and this CIDR range basically belongs to the VPC only, are a part of VPC only. Okay. Then in the default VPC we have a internet gateway. Okay, like in our let's say at our home we have router or Wi-Fi. So those Wi-Fi or router is basically connected to an ISP, okay, internet service provider, right? So the same way here in the cloud we have a internet gateway, which basically connects our instances, our network to the internet. Okay, which connects to the internet. Okay, and this internet gateway, this route table is connected to the has a route. Okay, we cannot say that it is connected to the internet gateway. It has a route to the internet gateway. Okay, it will look something like this, that any network coming from 0.0.0 will be pointed to internet gateway. Okay, and this in the route table basically we create this rule. Okay, so let's say we have one EC2 instance running. Like so far we used to launch a EC2 instance, and we used to connect to the EC2 instance, right? So if we see at the VPC level the way we used to connect more technically, so let's say this is a user trying to connect to the EC2 instance. Let's say this is the EC2 instance running, and a user is trying to connect to the EC2 instance. Okay, now the user is trying to connect to the EC2 instance through his laptop, right? But before that, he's connected to the internet. Okay, the user is first connected to the internet, and through the internet, he is going to the internet gateway, and through the internet gateway, he is going to the root table. Through the root table, he is going to the subnet, and through the subnet, it's reaching to the EC2 instance. So this is how basically we connect to the EC2 instance. It's not direct a direct connection. Like we are not directly reaching to the EC2 instance. We are actually first going through the internet gateway, then through the route table to the subnet, and through this from the subnet to the EC2 instance. Okay. Now all the EC2 so this is the architecture of the default VPC. Okay, this is the architecture of default VPC. Do you have any questions still here?
Yes. So then before the traffic goes to the subnet, it hits the has to go through the NACL, correct?
Sorry. Yeah, first it goes through the NACL and then through the security group.
Okay. But the NACL is more just like it has to pass the rules there, right?
Yeah.
Okay.
Yeah, usually we do not configure the NACL. We basically make changes in the security group.
Okay.
Okay, so this is the default VPC, and in default VPC, in any of the subnets, if we will be launching an EC2 instance, so that EC2 instance will be accessible over the internet, right? And the reason why the EC2 instance will be accessible over the internet is because it has a route through the internet gateway. Okay, it has a route to the to the internet gateway. Okay, so let's say if you see the default VPC in the console, so this is the default VPC. It has three subnets in each of the availability zones. It has a route table, and in the route table here you can see routes, and here you can see the rules, routing rules, or we can say the routes. And this is passing through the internet gateway, IGW, internet gateway. If we go here to internet gateway, so here you can see this is the internet gateway, and it is attached to the VPC. Let's say if the VPC doesn't have an internet gateway, then we will not be able to connect to our EC2 instances. Also, even if we are running any application in our EC2 instance, that application will not be accessible over the internet if we don't have a internet gateway. Okay, so this is the internet gateway which is attached to a VPC. Okay, one more thing to note here in terms of certification exam is, okay, the certification exam basically there is a question like how many internet gateways we can attach to a VPC. Okay, so we can only attach one internet gateway to the VPC. We cannot attach more than one internet gateway to the VPC. Okay, now we have the default VPC, and each of these, yeah, if we go to route tables, so this is the route table, and if we go to subnet association, so we'll be able to see the subnets which are associated with this route table. Okay, these are the subnets which are associated with this route table, which are all the subnets are associated with this route table. And each of these subnets have this route. Okay, because they belong to this route table, so they are following these routes. And this route is basically connecting it to the internet gateway. And if it's connecting to the internet gateway, then the resources which will be launching in these subnets, the resources which will be launching in these subnets will be accessible over the internet, right? So when we launched the EC2 instance, we used to skip this part, which was the step 3. Yeah, the step 3, configure instance detail. So here you can find network and subnet. So in network, basically we choose the VPC. Okay, and which VPC we want to launch the EC2 instance in. Then we have to choose the subnet. And subnet basically defines in which availability zone your instance will be running in. Let's say if you don't have a subnet in any of these availability zones, so you will not be able to launch instance in that specific availability zone. Okay, so at the time of launching the EC2 instance, we choose the VPC as well as the subnet. And as all these subnets have a route to the internet gateway, so they will be accessible over the internet. Okay, they will be accessible over the internet. Okay, now let's say we want to run a two-tier application. Okay, a stateful application. Sorry, a stateless application. Are you aware about stateless application? Any stateless application?
No.
Yes, so stateless is basically a two-tier application which has a database, or is which is basically preserving some data. One architecture. sorry, stateful application. Stateless is without database, just a front end. Yeah, yeah, we can see this one. Yeah, any application which is connecting to the database or basically storing any kind of information is basically a stateful application, where some data is basically preserved. After every session or after every user is connected to the application, some data is recorded or is stored, some session is stored. So those kind of applications are called stateful application. Like Gmail. Gmail is a stateful application where basically we are logging in, we create our Gmail account, we store our, like we send our emails, right, which are indirectly basically stored in Google database, right? So Gmail is a stateful application. Okay, whereas if we talk about stateless application, so any static website where we are not logging in, okay, there is no sign up or is just displaying the information, okay, is basically a stateless application where there is no interaction, okay, like there is no sign up form or login form, okay, so those kind of applications are stateless application. Okay, now let's say in the default VPC we want to deploy a stateful application. Okay, stateful also we can understand it this way, two-tier application. Yeah, so in two-tier application also we have the same two things, which is a front end and a back end. Okay, backend is basically the database, or it will be storing some any kind of data. Okay, any kind of session files or any kind of data, it will be storing. And front end is basically the UI, okay, the user interface. Okay, like Gmail. So we log into Gmail. So Gmail is basically the UI which we see in our browser. That is the front end, and the back end is the database. We are not aware about where the database is, right? But Gmail is connecting to a database where it is basically storing our username, password, and other information, right? So that is the back end. Okay, we only interact with the front end. We do not interact with the back end. Even we don't know what database they are using, what application they are running, or whatever they are running. We are not aware about that, right? In the backend, right? And backend is not accessible to us. Only front end is accessible to us, right? The reason is they have kept, for security purpose, basically they have kept backend private. Okay, for security reasons they have kept the backend private. Why? Because in the backend they are storing the user information, like any user sensitive informations like credit card details, username, password, those kind of information. Basically, they are storing in backend, and we don't have access to the backend, right? Even we don't know what software or what technology they are using for storing the data in the backend, right? Now let's say if you want to deploy a same like an application same as, let's say, Gmail or Facebook, or any kind of application similar to this which has a front end and back end. Okay, anywhere we are seeing sign up or login page, that is basically a two-tier application, which is basically storing some user data, right? So let's say we want to deploy a front end and back end application. So we'll be deploying one EC2 instance. Okay, and one EC2 instance for the front end, and let's say one EC2 instance for the back end. Okay. Now, if we are doing it in the default VPC, so both as the instances have, as the subnet has a route to the internet gateway, so both the instances will be exposed to the internet, right? Both the instances will be exposed to the internet. Okay, both the instances will be exposed to the internet, right? But we don't want this backend to be exposed over the internet. Okay, because in backend, let's say we are storing some user data. Okay, we are storing user data. We are storing, let's say some, let's say invoices which are generated by the application, or we are storing some confidential data of user, and we don't want that to be accessible over the internet. Okay, for security reasons, right? So what we want to make is we want to make this in a private network. Okay, like this instance will be running in the public network which will be accessible over the internet. Private network is only accessible locally. Okay, currently my machine, my desktop, and your laptop is connected to a private network. Okay, now let's say I want to SSH to your machine. Okay, or SSH to any of the machine in the world, like who are using desktops. So that is not possible, and the reason is they are in a private network, which is also called a LAN network, which is also called a LAN network. It stands for local area network. Okay, which is also called a local area network. So we want to create a local area network in AWS. Okay, where in that local area network we can store our any kind of confidential data or databases or any kind of password which we want to store inside, right? So for that, basically we want to create a private network, right? And in default VPC we cannot do that. Okay, in the default VPC we cannot do that. We can do that, which means we have to customize the VPC. Okay, and if we customize the VPC, then it will no longer be the default VPC. Okay, because it will not have the characteristics of a default VPC, right? So basically, to create this public and private network, so to create this public and private network, we create a custom VPC. Okay, because those things we cannot achieve in the default VPC. Any resource which is created in the default VPC is accessible over the internet. Is created in the public network, and it can be accessible over the internet, right? And hence we create a custom network for creating public and private network. Private network for storing, like for deploying our databases, okay, or any storage server, which we don't want to be accessible to the end users. And in the public network, we'll be deploying the front end of the application, which will be accessible to the users, right? Okay, now we'll be talking about how we'll be creating a VPC. Okay, so if we go to the console, so here we have the option at the right top, create VPC. So first we have to give the VPC name. Okay, let's say my VPC. Then the CIDR. Okay, the CIDR is very much important. This is basically the network range of our VPC. Okay, and here we can only provide private IP addresses. We cannot provide any public IP here. Are you familiar with public and private IP?
So I guess the public IPs are accessible to the internet, and the private IPs are not.
Yeah, yeah. Also, in private IP, we have classes. Private IP classes. Class A, Class B, Class C, Class D, Class E IP addresses. So that is basically a reserved range of, yeah, these are the reserved range of private IP addresses. Okay, this is of IBM Cloud. Yeah, Class A. This is the network range of Class A network. Class B, Class C, Class D, Class E. So these are basically network range of private addresses. Okay, IP address ranges of private addresses. Okay, and these are reserved, and these are basically determined by this is basically created by INA. Okay, Internet Assigned Number Authority. So these guys are basically set the IP address, like what will be the private IP address, what will be the range of the private IP addresses, what will be the range of public IP addresses. These guys have set that standard. Internet Assigned Number Authority. Okay, so in AWS VPC, there is basically a VPC range already defined. And we have to create the VPC in that range only, which is the yeah, VPC and subnet sizing for IPv4. So yeah, here they have given the network ranges which we can use for our VPC. Okay, your VPC must be /16 or smaller. Your VPC must be /16 or smaller. Yeah, and here they have given some example of CIDR range. So we can create a VPC only of these ranges. Okay, which is from the standard RFC 1918. Okay, this is basically a standard.
Does it matter which one out of those three that you pick?
Yeah, it depends in terms of how big network we want to create. So if we see, if we'll be creating a network of this range, 10 range, so it will be having a lot of IP addresses, because this network is starting from, it has a prefix of 8. The lower the prefix, the more we will be having the IP addresses in that particular network. So here we have prefix 8. So here we'll be having more than I would say 60,000 IP addresses in this prefix. If we'll be having 12, so it will be less than this network. If we'll be having 16, then it will be less than this network. So it completely depends upon how many resources we want to deploy inside our VPC. So depending on that, basically we choose a CIDR range.
Okay. So if you're planning on launching a large amount of resources within your VPC, then you would choose the range with the lower prefix.
Sorry?
If you would like to launch like a large amount of instances within your VPC, then you would choose the IP address range with the lower prefix. Is that correct?
Yes, exactly.
Vice versa. Okay. So do most well, I guess so enterprise applications would be more on the lower prefix range, And then the mid-tier would be in the middle, and the smaller applications would be like the larger prefix screens.
Yeah, it actually depends completely upon the infrastructure, like how many instances we will be running and how many database we will be having. It completely depends on that. Also, when we create a CIDR, so there are 5 IP addresses which are already reserved by AWS. Okay, let's say we are creating a network for 5 IP addresses. These 5 IP addresses are already reserved by AWS. And this can also be asked in the certification exam, like what are the 5 IP addresses which are reserved by AWS? And what each of the IP address basically means. So let's say if we are creating a network of this IP address, which is ending with 0. Okay, this number could be anything. If it is ending with 0, so that is the network address. Then if it is ending with 1, so it is basically reserved by VPC router, okay, which is also called a gateway. Okay. Okay, this is basically the CIDR range and is reserved by AWS. Then 10.0.2. This is also reserved by AWS and it is basically used for DNS purpose. Okay, it is used for DNS purpose. Then we have 10.0.3, which AWS has reserved for future use, which is right now not in use, but AWS has reserved for future use. Then we have this one, which is ending with 255. Okay, any network, I mean any CIDR range, it starts with 0 and end with 255. You will not never see a network with let's say 257 or 300 or 400. It starts with 0 and end with 255. And these numbers can also be in between 0 to 255. It cannot be 500, 600, 700. It cannot be like that. Okay. Then this is basically the broadcast, network broadcast address. We do not support broadcast and VPC, therefore we reserve this address. Okay, so this address, this IP address is basically the broadcast address and is basically reserved by AWS. So 5 IP addresses, when we create a VPC, 5 IP addresses are already reserved by AWS. Okay, I'll send you this link.
Oh, thank you.
Actually, you'll find on the book also.
Okay.
Yeah, you can go through the book also, and I would recommend more going through the documentation. The reason is documentation is more updated as compared to the book. Book is of 2019, and documentation, if they make any changes, so they basically first update the documentation. So documentation is more up to date. Yeah, so first we have given the VPC name, then we have to give the CIDR range. So we'll be using this CIDR 10.0.0.16. Then we can also create a IPv6 CIDR block also. Right now here we are creating IPv4 CIDR block. We can also create a CIDR of IPv6. Are you familiar with IPv6?
Yes, so that's has a lot more digits to it than the IPv4. It's like a longer range of digits.
Yeah, exactly. But currently IPv6 is not much in use. Currently we are using only IPv4. IPv6 is basically designed because of the shortage of IPv4. Okay, like almost 70-80% of IPv4 addresses are already in use. Okay, and IPv6 basically has 16 octets, not 16, sorry, 8 octets, whereas IPv4 has 4 octets. Okay, and IPv6 supports hexadecimal. Okay, whereas IPv4 doesn't support hexadecimal IP addresses. Okay, hexadecimal, it means it will come with alphabets also. Yeah. So depending on our use case, if we are going to run any application on our VPC which requires IPv6 network, so in that case we'll be using IPv6. If our it is not using, if our application doesn't requires IPv6, then we can go with no IPv6 EIDR block. Okay, but it is completely free. If you want to use IPv6, that is also fine. There is no additional charges of using it. Even for creating the whole VPC, there are no charges. Okay, the default VPC which AWS has created, we are not charged anything for that. Then we have tenancy. Okay, so we have two types of tenancy: default and dedicated. Okay, and default tenancy, basically our instance, our the network VPC network will be created across a shared hardware. Okay, and if you'll be going with dedicated, so it will be created on a single hypervisor. Okay, like in EC2 we learned about dedicated host, right? So the same concept applies here too. Like if you will be creating in default, it will be, the network will be spread across multiple EC2 instances. Sorry, multiple hypervisors in the data center. Whereas if we'll be creating it to dedicated, it will be running on a dedicated hardware. And if you'll be creating with dedicated, so there is additional charges for that. Then here we click on create VPC. Okay, and the VPC has been created. Okay, this is the VPC which we created. This is the default VPC, and this is the VPC which we created. We can also name it as default VPC, just to avoid confusion. Yeah, so this is the default VPC, and this is the VPC which we created, right? And if you see here in details, default VPC is set to no. Now there are some resources which are created when we create a VPC. Okay, when we create a VPC, the following resources are created. Resources are created by default. Okay, first is a route table is created. So like when we created the VPC, a route table is also created. If we go here to route tables, so here you can see a route table is created, and this is created for the VPC which we created. So when we create a VPC, a route table is created, then a security group is created. And a NACL is created. Okay, which is basically also called as default security group. And the one which is created, the one NACL which is created is called default NACL. Okay, so when we create a VPC, a route table is created, a default security group is created, and a NACL is created. So these are the three resources which are created when we create a VPC. If we go here to the console, if we go to NACLs, so here we can see this is the NACL which is created. If we go to security groups, this is the security group which is created for that VPC, the one which we created.
So the default security group and default NACL, isn't it like one of them lets in all traffic and one of them doesn't by default? Or
Sorry?
when you're creating a custom VPC, does the security group allow all traffic by default and you have to adjust it, or is it denies all traffic by default and you have to adjust it?
It denies everything. If you go here to inbound, so it is only allowed to its own, its own network. I mean, it's only allowed to its own security group. I mean, it's not exposed over the internet. And same if we see for NACL is open. By default, NACL is open. And if we see the rule of default VPC also, that is also open. Okay, we created this VPC with IPv6 also. Hence, we have two more rules which are of IPv6. Okay, so when we create a VPC, a root table, security group, and NACL is created, right? Now, what we'll be doing, we'll be creating subnets. Okay, now we'll replace this by a custom VPC.
So the custom VPC does not include any subnets.
Yeah, currently it doesn't have any subnets. There is no subnet, there is no routes. Yeah, so currently we have this thing, like we have just created a VPC, and that VPC has created a security group, a route table for us. And the default route table is also called main route table. Okay, the route table which is created by AWS. When we create a VPC, a route table is created. So that route table is also called main route table. Okay, if we go to the console, if we go here to route tables, so this was the route table which was created by AWS. And here you can see one setting which says main and it is set to yes. So this is the default route table. When we create a VPC, a default route table is created which is also called main route table. Okay, there is one characteristic also of the main route table that we'll see later when we'll be creating the subnets. So this is the main route table which is created by AWS. Now we will be creating subnets. So we have 3 availability zones. So always it is recommended that when we are creating the network or when we are creating the subnets, it's always recommended that we create a very robust network, okay, which is highly available. Okay, which is highly available. So in that case, what we'll be doing in each of these availability zones, we'll be creating a subnet. So in case if any of the availability zone gets down, so we'll be having one subnet up and running, right? We'll be having at least one subnet available in any of the availability zone where we can provision our resources, or if we already have resources running in that availability zone, so those resources will not be affected, right? Okay, so we'll be creating 3 subnets, and each of these subnets will be creating in one availability zone. So here we'll click on create subnet. Then in which VPC we want to create the subnet. So this is the VPC which we created. Then we have to give the subnet name. So let's say subnet 1. Then in which availability zone we want to create the subnet. If we set it to no preference, it will automatically choose a random availability zone. So we will choose this availability zone. We'll be creating it in the first availability zone. And we can actually also name it as 1A, which will also give the availability zone, like it is running in first availability zone. Then the CIDR range of that subnet. And this CIDR range must belong to the same, must be of the same range of the VPC. Okay, let's say you have created with the CIDR 10.0.0. So the subnet should also be of the same CIDR. We cannot create of, let's say, some different network 172.168 or 192. Of that network we cannot create. It should belong to the CIDR range of the VPC. Okay, so here basically we are splitting the network. Here we are creating a small network which is 10.0.1.0/24. And then if you want to assign the CIDR range, like if you want this subnet to have a IPv6 network, so we can enable IPv6. Okay, then we click on add another subnet. Okay, let's say subnet 2B. And this will be creating in the second availability zone. Then again, new subnet 2C. This is in the third availability zone. And then create subnets. Okay, so we just created 3 subnets. Subnet 1 is subnet 2B and subnet 3C. Okay, so we created 3 subnets. Right, as per the diagram, we created 3 subnets. And the characteristic of the main root table is whenever we create a subnet, so it automatically gets associated to the main root table. So right now we created these 3 subnets. So automatically they are associated with this main root table. Okay, subnet cannot be without a root table. It will always be in a root table, right? If you go to the console, if you go to root tables, this is the root table. If you go to subnet association, so here you can see explicit subnet association, and it says you don't have any subnet association. But if we scroll down, so here it says the following subnets have not been explicitly associated with any route tables and are therefore associated with the main root table. And here you can see all the 3 subnets which we created. So by default, when we create the subnet goes to the main root table. Okay, it goes to the main root table. Okay, now the next thing is we'll be creating a internet gateway. So here we'll click on create internet gateway. Internet gateway is basically for creating the public network. Right now, the network which we have created is a private network. And this private network cannot go outside to the internet. Okay, no one cannot reach to this network. Let's say if we launch a EC2 instance now in any of these subnets. So that EC2 instance will not be able to connect to that EC2 instance. And that EC2 instance will not be able to connect to the internet also. Okay, so we just created an internet gateway, and when we create the internet gateway, by default, it is not attached to any of the VPC, right? So we have to attach the internet gateway to the VPC. Okay, and to a VPC we can only attach one internet gateway. So now here you can see the status changed to attach. Earlier it was detached. right? So right now what we did, we just created a internet gateway and we attached it to our VPC. Okay, so we have created the internet gateway and we attach the internet gateway to our VPC. Now we will be creating routes in the route table. Okay, so this is our route table and this is the main route table. We'll just rename it to main route table. Okay, and here we go to routes and here we'll click on edit routes, add routes, and then destination will be 0.0.0/0 and target will be internet gateway. Okay, 0.0 basically we already know, like we saw 0.0 in security group also, which means any IP address. Okay, any IPv4 IP address. And we are passing the traffic through internet gateway, which means anyone from the outside will be able to connect to our instance over the internet. Plus, from the instance, we'll be able to connect to the internet as well, right? Okay, so this is the rule which we created. So what we actually did is we added a route to the internet gateway. And once we do that, then basically we have created a gateway for the outside people, outside, I mean the internet to reach to these subnets. Okay. So right now, so far, if we see, we have designed a public, I mean, a default VPC. This is how basically a default VPC looks like. Okay, it has three sub. I mean, in all of the availability zone, it has one subnet. It has an internet gateway which has a route to the. I mean, it has a route table which has a route to the internet gateway. It has a internet gateway which is attached to the VPC, right? So this is basically, and all these subnets, basically we can call it as public subnet. Why public subnet? Because these subnets are associated with a route table which has a route to the internet gateway. And hence we are calling it as public subnet. All these subnets currently are public subnets because they have a route to the internet gateway. They are associated to a route table and that route table has a route to the internet gateway. Hence we are calling it as a public subnet. Okay. Okay, so this is basically how a default VPC looks like. Okay, we just right now we just created, we can say another default VPC. Same, like we can call it as a clone of default VPC. Only we created a different CIDR, right? Other than that, all the characteristics, all the I would say the architecture is same as the default VPC. So in the default VPC, all the three networks are public network. Now we'll be seeing how we can create a private network or private subnet. Okay, to create a private subnet, what we'll be doing, we'll be creating a custom, I mean, we'll be creating another route table. We'll be creating one route table. And instead of connecting, let's say we want to create this subnet as a private subnet. So what we will be doing, we will be connecting this subnet we will be associating this subnet with this route table. And once we do that, it will not have a route to the internet gateway. And if it doesn't have a route to the internet gateway, then outside people will not be able to reach to this EC2 instance, to this network, right? So in the console, we'll be creating a route table, and we'll call it as private route table. We'll be creating in our VPC. Then here we'll go to subnet association. And here we'll click on edit subnet association. And here, currently all these subnets here you can see belong to the main route table. All the three subnets belong to the main route table. And the main route table has a route to the internet gateway, right? So now we will add this subnet. Let's say we want to make this subnet as the private subnet. So we'll add this subnet to this route table. Which route table? Private route table. So if we go here, if we click on this private route table, so here you can see, if we go to subnet association, here you can see one subnet is associated with this route table, which is subnet 3, right? So we have created something like this, like in this subnet we have associated with this route table, which is our private route table.
And each subnet, can they only be associated with one route table at a time?
Yes, exactly. It can only be associated to one route table at a time. Yeah. Now, okay, now as it doesn't have a route to the internet gateway, so the resource, let's say if we launch a EC2 instance, the EC2 instance will not be, the EC2 instance, the private subnet, currently in the private subnet, will not be able to connect to the internet, nor it will be accessible over the internet. Okay, so the instances or the resources which we'll be creating in the private subnet will not be able to access the internet, plus it will not be accessible over the internet, right? Whereas public subnet will be completely opposite of this. It will be able to connect to the internet, plus it will be accessible over the internet. And the reason is because it has a route to the, it is basically associated to a route table which has a route to the internet gateway. And this subnet is associated with a route table which doesn't have a route to the internet gateway, and hence it cannot connect to the internet, nor it cannot be accessible over the internet. From outside also it is not accessible, and from inside also it cannot access the internet, right? And that's basically what we wanted, right? But there is a problem. The problem is the private, like the problem is, like we have solved one problem, which is it will not be accessible over the internet, right? This is what basically we wanted. Like we'll be running our backend server here, and we don't want this backend server to be accessible over the internet. So that problem is solved. But we still have one problem, which is this problem. which is it will not be able to connect to the internet internally. Okay, let's say if we take an example of our laptop. Now let's say I want to connect to, let's say your laptop I want to connect through SSH. So I'll not be able to connect to it because it is running in a private network, right? So the same way this instance is also running in a private network, I cannot directly connect to this server. Okay, and and another thing is I cannot access the internet in the instance, right? We cannot access the internet in the instance. Okay, right now at our home, basically we have a router, and through that router, basically we are connecting to the internet. So the same way here also we have to create a resource which will be allowing this instance to connect to the internet. Okay, not instance, allowing this private subnet to connect to the internet. Okay, it will, after we create that resource, so it will be able to connect to the internet, but it will not be accessible over the internet. The resource will stay isolated, but it will be able to access the internet. Okay, like our laptops, it is not, our laptops are not accessible over the internet. No one can directly connect to our laptop, right? But in our laptop we can access the internet. So the same thing we want here, that our EC2 instance must be able to connect to the internet, but it should not be accessible over the internet. Okay, like in our laptop also we are storing our personal data, like personal images, videos, documents, right? The same way this instance also we are going to use to store our let's say our user data. Okay, like databases or any confidential data we want to store, right? But we want this instance to connect to the internet, right? Why we want this instance to connect to the internet? Let's say we want to install some softwares. Okay, so for that basically we want to connect to the internet, or let's say we want to install some security patches. Okay, patches are accessible over let's say over the internet, right? So in that case basically we want our instance to connect to the internet, and currently there is only one way, which is connecting it to the internet gateway. And if we connect it to the internet gateway, then it will start acting as a public subnet, which means it will be able to access the internet and it will be accessible over the internet, which we don't want. Okay, we want it should access the internet, but it should not access. It should not be accessible over the internet, right? Do you have any questions still here?
No.
Okay, so to allow the instances or the resources which will be running in the private subnet to connect to the internet, we'll be using a concept of natting. Are you aware about natting?
No.
NAT basically stands for network address translation. Anyone who is accessing the internet all over the world is basically using the concept of natting. Okay, only in servers, in server we don't have natting. Actually, in most of the servers, we don't have natting. Servers are actually exposed over directly over the public IP. Okay, so currently, like right now, I am connected to the internet. You are connected to the internet. We are connected to the internet with this concept of natting. So right now at our home we have a router, and through this router our phone is connected, our laptop is connected, our desktop is connected, our television is connected, right? Lot of resources, lot of devices are connected to this router. Now there is a prerequisite to connect to the internet. Okay, all of these machines are connecting to the internet, right? But there is a prerequisite to connect to the internet, or we can say there is uh, one requirement to connect to the internet, which is public IP. If you have a public IP, then only you will be able to access the internet. If we don't have the public IP, then we'll not be able to connect to the internet, right? If we don't have a public IP, we'll not be able to connect to the internet, right?
Yeah.
So in that case, each of these machines or each of these devices, let's say phone will be having a public IP, a laptop will be having a public IP, desktop will be having a public IP, the television also will be having a public IP, right? If we start assigning, and each of the device will be having a unique IP, must have a unique IP. Public IP is basically a unique IP address. Okay, let's say if, in my machine I have a public IP, so that IP address in the world cannot be used. Okay, unless my from my router that IP address is released. If it is assigned to my router, no one in the world can use that IP address unless it is released from my router, right? So each of these devices will be having a unique IP address. This will be having one unique IP. Let's say dot 8 dot 2 dot 1 8 dot 8 dot 3 dot something. So each of these machines will be having a unique IP address. I mean, that is the requirement to connect to the internet. Okay. Now let's say if we start assigning each of these devices a unique IP address, so there will be actually two problems. One is a major problem and another is a minor problem. The major problem is if we start assigning each of these devices a unique IP address, then there will be a shortage of IPv4 address. Okay, there will be a shortage of IPv4 address. And the minor problem would be pricing. Okay, if we'll be having each of the devices will be having a unique IP address, so like it will be like having four routers at our home. Okay, the cost will be 4 times. Let's say if we want to connect internet to 4 devices with unique IP address, so we need like the charges of the internet will be 4 times. Okay, so pricing will be a lot. Another problem is shortage of IPv4 address, right? So to overcome this problem, we have the concept of NATing. So NATing basically, we instead of assigning each of these devices a public IP, we assign the router a public IP address. Okay, let's say this is the IP address of the router. So we assign a public IP address to the router. And each of these devices will be having a private IP. Okay, each of these devices will be having a private IP.
Do private IPs have to be unique?
Yeah, private IP will also be unique. Okay, private IP will also be unique. Okay, private IP can be anything. Let's say unique, it means it should be unique in a local area network. Okay, at my home also I can have the same IP. Okay, at my home also I can have the same IP, and this IP can be used anywhere in a local network. In a LAN network, this IP can be reused. Okay, but in a WAN network, which is wide area network, which is the internet, we cannot use same. We cannot assign public IP same public IP. It is actually not possible to assign same public IP to multiple devices. Okay, so basically we use the concept of NATing, and with NATing, NAT basically provides a private IP to all the machines. And then it basically what it does, it basically forwards the internet packets to the network. Now, in each of the device, if we type what is my IP, so each of the devices will be showing which IP, this IP, this IP, this IP, this IP. So each of the device will be showing this IP address. So here we have solved two problems. One was the major problem, which is of IPv4 shortage. Another problem was costing, right? So we have solved two problems with this concept, NATing. And the same concept of NATing basically we use in AWS to access the internet in our, let's say this is our laptop. So with this concept of NATing, we'll be able to access the internet in our laptop, right? So the same way, to allow our EC2 instance to connect to the internet, what we will be doing, okay, so what we'll be doing, we'll be connecting it to the router. Sorry, we'll be creating a NAT gateway. In AWS, basically, we have two things. One is NAT gateway and NAT instance. Okay, NAT instance is something which is now almost deprecated. Okay, like before 2 years, basically, we used to see the questions and the certification related to NAT instance, which was difference, but not difference. I mean, um, yeah, questions related to NAT instance. What is the instance we launch in NAT for setting up the NAT network? So before 2 3 years, basically AWS basically used to provide NAT instance. Okay, after that they replaced it with NAT gateway. Currently also we have the concept of NAT instance, but it's like more like it's deprecated. Okay, it's costly also, and it has a lot of management also for us to do, for the customer to do. Whereas NAT gateway is managed by AWS and is cheap as compared to the NAT instance. Okay. So basically what we'll be doing, we'll be creating a NAT gateway. Okay. Now NAT gateway is created in the public subnet. Okay, this can be asked in the certification exam. Like in which subnet we create the NAT gateway? NAT gateway or NAT instance. In which subnet we create the NAT gateway? So we create the NAT gateway in the public subnet. Okay, in the public subnet. And when we create the NAT gateway, we have to create a EIP, elastic IP. We need to create a EIP, elastic IP. So basically, elastic IP is what? Elastic IP is basically a static public IP. So we basically associate the static public IP to our NAT gateway. A NAT gateway we create inside the public subnet. So we'll be creating a NAT gateway in the public subnet. And then we'll be creating a route in the private subnet, which will be going through the NAT gateway. So if we go to the console, we go to NAT gateway. Here we'll click on create NAT gateways. And here we'll give the name of the NAT gateway. Let's say my NAT gateway. Then it is asking in which subnet we want to create the NAT gateway in. So we'll be creating it in the public subnet. What is the public subnet? The subnet which is associated to a route table which has a route to the internet gateway. So this is the subnet. This is the subnet which we created in the which is associated with the route table which has a route to the internet gateway, and hence it is basically a public subnet because it has a route to the internet gateway. Then we need to create a elastic IP. Okay, so AWS will automatically create an elastic IP and associate to our NAT gateway. Then we click on create NAT gateway. So if we go to NAT gateways, so currently it is in creation state.
Do you have to manually create your Elastic IP, or do you have one automatically that you can just associate, like a default one?
No, we don't have any default Elastic IP. We need to create it.
Okay.
Okay, once this NAT gateway is created, we'll go to route tables and we'll go to our private route table. And in our private route table, we'll create a route. Here we'll click on add routes. And this will also go through any IP address. And target will be NAT gateway. Target will be our NAT gateway. Okay, target is our NAT gateway. Okay, so we have associated, we created the NAT gateway in the public subnet, and after that we associated this NAT gateway, we created a route inside our private route table through this NAT gateway. And after that, the instances which will be launched in the NAT gateway will be able to access the internet. Okay, do you have any questions still here?
Let's see. So now the instance is able to connect to the internet. Are you able at this point to SSH into the private instance?
Yeah, we cannot directly SSH to the private subnet instance. The reason is because it is not accessible over the internet. So to connect to the instance which is in private subnet, first we have to connect to the instance which is running in the public subnet. First, we need to connect to the instance which is running in the public subnet, and through this instance, we'll be able to connect to the instance which is running in the private subnet. We cannot directly reach it through the internet. So through the public subnet instance, we have to connect to the private subnet instance. Okay. Do you have any other question?
Can you remind me how many Elastic IPs you can have per account? Isn't there a limit on that?
Per region, per region. It is five elastic IPs per region.
Gotcha.
And 5 VPCs per region. We cannot create more than 5 VPC in a region.
Okay.
Okay, let us have a break of 5 minutes, and then we'll continue with. We'll start with the NACLs and security groups and everything. Okay.
Okay. Sounds good.
Okay. In terms of pricing, we are only charged for NAT gateway. We're not charged for creating VPC route tables, subnets. We are only charged for creating NAT gateway. There is an hourly charge of NAT gateway.
What is the average, I don't know, cost per year for an NAT gateway?
It is, yeah, this is the hourly charge, 0.0.045 cents per hour. Yeah, and it also varies in terms of, I mean, the same price is, I mean, if we are downloading any data through the NAT gateway, so we have to also pay an per GB price, which is same as the hourly rate. Yeah, so we are charged for the NAT gateway as well as if we are downloading or basically for the data transfer also we are charged. Okay, do you have any questions still here?
Nope.
Okay. Okay, now we'll be talking about NACLs and security group. We have one more topic in VPC. Actually, two topics. One is the endpoints and one is VPC peering. VPC peering we'll talk after, I mean, after discussing security group and NACL. And we have one more topic which is endpoint and endpoint services. So this we will be talking when we'll be done with S3, because to do the, I mean, it has some relationship with S3 service. Okay, so we'll be talking about endpoint and endpoint service when we are done with S3 service of AWS. Okay, so now let us talk about security group and NACL. Security group we already talked in EC2, and we are um, okay. We already talked in EC2, and also security groups um, are mapped with us VPC. Okay, we cannot use. Let's say we have created one security group in VPC A, and we want to use the same security group in VPC to an instance which is running in VPC B. So that is not possible. Okay, we can only use the security group for the resources which are running in the same VPC. Okay, and we can create up to 1500 security groups region in a region, or we can say in a VPC. Do you have any idea about NACL?
Yeah, so the network access control list,
Uh-huh.
like a list of rules for the traffic in order for the traffic to reach the, I guess, security group, or I'm sorry, the subnet.
Okay. Okay, so okay, yeah, so NACL is basically working at the subnet level. Okay, like whereas the security group which we create basically are at the instance level. Okay, so when we create a NACL, so NACL is basically associated with the subnet. Okay, right now here you can see this is the default NACL. Like when we create a VPC, the NACL is created, which is called the default NACL. Sorry, default NACL. And if we go to subnet association, so here we can see the subnets which are associated with this NACL. Okay, so subnets are basically associated with NACL. The same way subnets are associated with the root tables, so the same way subnets are associated with NACL as well. Okay, we cannot delete the. This is the default NACL. Okay, we cannot delete a default NACL. Let's say if you want to delete this, so we cannot delete it because there should be at least one NACL and one route table in the VPC. At least one route table, one NACL, and one security group inside the VPC. At least one, minimum one. Okay, and when we create a subnet, the subnet automatically gets associated with a root table and with the NACL. Okay, and in NACL, basically the same way. I mean, the same way we create rules like inbound, outbound rules in security groups. So the same way we create in NACL as well. Okay, but in security group we only create allow rules. Okay? If we do a comparison between security group and NACL, both are doing the same thing. Both are basically for network security. Both are basically acting as a firewall. Okay, in NACL supports both allow and deny rules. Okay, NACL has both allow and deny rules, whereas security group it only has allow rules. We can only create allow rules. We can say we can only create allow rules, right? And all traffic is denied. Okay, all traffic is denied. We only create allow rules. Okay, and we cannot change the deny rules in security group. Okay, we can only create allow rules. By default, all traffic is denied. All ports are blocked. Okay, or you can say all ports or all traffic is blocked. We can only create allow rules. Whereas in NACL, we can create both allow and deny rules. Next thing is NACL work at the subnet level, whereas security works at the instance level. Okay, whereas security group works at the instance level. NACL is stateful. Okay, NACL is stateful. What does this stateful means here? Stateful means if any changes if we are making in if we are making any changes in the in the NACL, let's say in the inbound, so automatically that rule will be applied in the outbound. Okay, if we are creating any rule in the inbound, automatically it will be created in the outbound. Okay, so and hence we basically call it as stateful, whereas security group is stateless. Okay, security group is stateless. Oh, sorry. I think it, yeah, sorry. It is actually other way around. It is NACL is stateless NACL is stateless and security group is stateful. Okay, and the reason we are calling NACL as stateless is any rules which we create in inbound, it also it also create the rule in the outbound. Uh, whereas in security group, the outbound rules are not affected. Okay, there is no dependency, we can say. Now in NACL we have a rule list. Okay, and in the rule list, each rule allow or deny has a rule number. The lower the number, the higher the precedence. Okay, the lower the number, the lower the rule number, the higher the precedence. Okay, which means, let's say, here you can see when we are creating a rule in NACL, so we have to give a rule number. Okay, so let's say in NACL we have, let's say I'm creating a rule, let's say 102, and here I am saying deny all traffic. So this rule will not be read. Okay, this is rule number 102. So basically what NACL does it will check each of the rules. Not each of the rules. It will start from rule number 1. And if rule number 1 matches, let's say this is rule number 100, we can start creating from rule number 1. If rule number 1 matches, then what will happen? It will be able to connect to the if the rule number 1 matches the request. Okay, let's say someone is trying to do SSH, and the SSH is coming inside this request, all traffic. So it will allow it. It will not check the second rule, third rule, fourth rule, or fifth rule. If any of the rule number is matching the request, it will basically take an action, whether allow or deny. Okay, it will either allow it or it will deny it. It will not read all the rules. Let's say in the third rule we are saying deny the access, but it will not deny it. It will only read the first rule, and if the first rule says allow, it will allow the access. It will not go to rule number 3, which is rule number 102. So the lower the rule number, the higher the precedence. So rule number 100 will get higher precedence as compared to rule number 102. Whereas in security group, it basically reads all the rule numbers. Okay, it reads all the rules in the security group. And in here we have each of the rules have a rule number, and the lower the number, the higher the precedence. Okay, if a request is matching, and if the request is same as if the request is matching any of the rule number which has lower precedence, lower number, rule number, and if it says allow, so it will allow access. If it says deny, so it will deny the access. It will not go to other rules. It will not read any other rules. Okay, do you have any questions still here?
Yes. So just for the stateful versus stateless, let's see. So NACL. Right. So NACL being stateless, does that mean that the inbound and outbound, like if you create a rule, it applies to both inbound and outbound? Yes. Okay. So I think so. And then for the stateful, you have to specify whether inbound or outbound.
Yeah. No. In stateful, it will, like, if we are creating a rule, So let's say we are creating a rule in inbound, so outbound will not be affected. Any changes will not be made in the outbound. Whereas in NACL, if we are creating an inbound rule, so the same rule will be created for outbound.
Okay.
Yeah, so these are the four major difference between NACL and security group. And there will be 100% 2 3 questions, in like there will be a question, let's say, uh, which of these is stateful. Okay, so you will get option like NACL, security group, subnet, none of these. So NACL is, yeah. So these kind of questions basically you'll be seeing in the certification exam. More will be like you'll see stateful and stateless and stateful, and like which works on the subnet level, NACL and this, and which of these, like in NACL or security, we can create allowed deny rules. So these questions, this kind of questions will be there in the certification exam related to NACL and security. Okay, do you have any question? And then this,
Yeah.
okay. Will be a diagram. Yeah, here you can see that NACL is associated with the subnet, whereas instances are associated with the security group. Okay, now we'll be talking about VPC peering. Are you familiar with VPC peering?
A little bit.
Okay, so let's say we have two VPCs. VPC A, VPC B. So we have two VPCs, VPC A and VPC B. And in VPC A, we have one instance running. And in VPC B also we have one instance running. Okay, and let's say the CIDR range of VPC A is 10.0.0.0/16, and VPC B has this CIDR. Okay, which is the CIDR of default VPC, right? Yeah. So we have VPC A, VPC B, and both of them have a different CIDR. Now what we want is we want to connect from this instance to this instance. Okay, from this instance we want to connect to this instance in through private IP. Okay, through private IP we want to connect to, from this instance we want to connect to this instance, right? So let's say we have, yeah, we have two VPCs. So what we'll do, we'll launch one instance. We launch one instance, we'll call it as VPC A, and we'll call the VPC as VPC B. Okay, so here we'll click on launch instance and we'll use this one, Amazon Linux. And this will launch in VPC A and will launch in the first subnet, which is our public subnet. And also we'll enable the auto assign public IP. We'll enable it so that our instance will have a public IP. This thing also we can enable in our subnet. Let's say if we have, this is the subnet which we created, right, for our VPC. And if we right click on it, and if we click on modify auto assign IP settings, and if we enable this, so our subnets will, like any resource which will be created in our subnet will be having a public IP. Okay, and that is basically an important setting. Okay, we are attaching 8 GB storage. And we'll add one, let's say name, instance in VPC. Okay, we'll create a security group. In security group, we'll add one more rule, one SSH and one more rule, which will be allowing ping access. Okay, ping access. Do you know what is ping?
No.
Ping is basically used to check whether a network is reachable or not, is reachable by another network or not. Okay, right now, let's say I'm connected to the internet and I want to check whether I'm able to connect to google.com or not. So we can simply do ping google.com. And if I do ping google.com, basically from the server, if I'm getting a reply, okay, here basically I'm getting a reply from the server. So which means I can uh, connect to google.com. Okay. And if I'm not getting this response, so we cannot connect to google.com or any network actually, not only google.com. Yes, so here we'll be creating a key pair, let's say for the instance in VPCA. Okay, so we just launched one instance which is running in VPCA. To verify this, we'll just go to networking and here we can see this instance is running in VPCA. Now we'll launch another instance. This instance we are creating in VPCB. Okay, so we just launched one instance in VPCB. So we have one instance running in VPCA and we have one instance running in VPCB. Okay, so now we'll connect to the instance which is running in VPC A. We'll do SSH EC2 user and the instance public IP. Okay, so we are connected to the instance which is running in VPC A. Now what we want to do is we want to connect to the instance which is running in VPC B. Okay, through the instance which is in VPC A. So what we can do is we can do SSH and we can SSH the instance private IP of VPC B. Okay, right now here you can see it is not reachable. Okay, if I try to ping it through ping also it is not reachable, right? Because it is in a different VPC. If it would be in a different same VPC, we'll be able to SSH to it. Okay, we'll be able to remotely from same VP. If it belongs to the same VPC, then we'll be able to do SSH to it. We'll be able to ping it, right? As it is in a different VPC, we are not able to reach it.
Okay. So once you're logged into, well, I guess right now you can't, but that's the purpose of VPC peering, is to allow, once you're logged into instance in one VPC, to then be able to SSH into the instance in the other VPC.
Exactly, exactly. Okay, so to connect to these two EC2 instances, we need to connect the subnet of these EC2 instances. So let's say this EC2 instance is running in a public subnet. Let's say like each of the instances will be running in a subnet. It could be public or it could be private, right? This is the subnet. And in the subnet, basically the instance is running. Right? Now what we have to do is we want this instance to communicate with this instance. The communication basically will be through a peering network. So we'll be creating a VPC peering connection. Okay, and then we'll connect these subnets with the peering connection. Okay, first what we'll be doing, we'll be actually connecting it through the VPC and then to the subnets. Okay, first to the VPC and then to the subnets. Now there is a prerequisite for creating VPC peering, which is the CIDR block. CIDR block of the VPC should not overlap. This is the prerequisite to create a VPC peering connection. Okay, which is the CIDR block of the VPC should not overlap. Okay. The CIDR block of the VPC should not, should not overlap. This is the prerequisite. And with VPC peering, we can connect two VPCs in the same region, in different regions, and in different AWS account. Okay, so let's say this VPC we have in AWS account A, and this VPC we have in some other AWS account B. So that also we can do. Those VPCs also we can connect using VPC peering. So VPC peering supports cross region and cross account. Okay, we can do peering cross region, cross account, and in the same region as well. But the only prerequisite is that the CIDR block should not overlap, which means if this VPC has this CIDR, so this VPC should not have the same CIDR. If it will be having the same CIDR, then we'll not be able to create the VPC peering connection. So if we go to the console, so we'll go to peering connection. And here we'll click on create peering connection. And peering connection name, say my peering connection. Then we have to choose a VPC to peer with. So let's say requester, we can make VPC as the requested and select a VPC to peer with. So it can be in our own account, it can be in some other AWS account also. If we choose another AWS account, so we have to provide the account ID. In our case, we'll go with my account and then region. Okay, region could be the same region and it could be some other region as well. So VPC peering is cross account and cross region. So in our case, we'll go with the same region, and here we'll choose VPCB. Here we have chosen VPCA, and here we are choosing VPCB. And also the CIDR range is different. Okay, it's not overlap. Then create peering connection. So here you can see requester VPC, acceptor VPC.
If it's cross account, does someone from the other account have to accept the
Exactly. Yeah. So currently, as we have created in the same account and in the same region, that's why basically it is showing here itself like pending acceptance. So we just need to click on it and accept request. Okay, once we do that, then what we have to do is we have to make some changes in the root table of the subnet. So in the root table, basically we'll add a route to the VPC peering connection. Okay, in the root table, we'll add a route to the VPC peering connection, and we'll associate that subnet to that VPC peering. Okay, to that subnet. To that routing table. So we have created the peering connection successfully, and it is set to active. Now we'll go to route tables. So we want, let's say this is the route table of VPC. This is the route table of VPCB, and this is the route table of VPCA. Now in VPCA route table, we'll go to routes. Then we'll click on edit routes. And here we click on add routes. And here we will be adding the route. And the route IP address will be the CIDR IP of that VPC. So let's say 172.16.0.0/16. So this is the CIDR of that VPC, and here target we will add it as peering connection, and then save changes. Okay, and in, in the root table of VPCB also we have to do the same. Okay, and once we do that, we should be able to ping it. I mean, we should be able to reach that instance. Okay, currently, we are not able to reach. We'll just check the rules. PCB. Okay, so currently we are not able to ping it. 172.31.35.48. So we will see 172.35.48, and we'll see the rule. So rule is also okay. Let's say if we try to SSH. Okay, so we are not able to SSH as well. So what we'll do is we'll just reboot the server. Okay, still we are not able to do ping. Okay, the CIDR range is wrong, and hence we are not able to do the ping. The CIDR of that VPC is 172.131. Sorry, dot 31. And once we change the rule, here you can see automatically it has started pinging it. Means it is reachable. That network is now reachable. And if the network is reachable, then we can do SSH. Okay. Now it is allowing us to do SSH plus we are able to ping it. Right.
Cool. And does it work both ways? Like you can access from either?
Yeah, yeah, yeah. Both ways it will work because we have added the routes in both the route tables. We can actually make it one way also, like that. This can only talk to this, or we can make both ways also. Currently, we have set up both ways.
Okay, and that's
Let's
just based on how you set up the route tables, right?
Sorry.
And that's based on how you would set up the route tables?
Yeah.
Okay.
Okay. Do you have any question in hearing?
Can you, like, what would be a real world example of when you might want to use that, the hearing?
Uh, yeah. Let's say we are running some resources in a, let's say in a, let's say in some other region. Okay, some other region, or we can say some other AWS account. Let's say we have a we have a database running, and we don't want that database to be exposed over the internet, but we want that database to be accessible to an instance which is running in some other VPC. So in that case, we can create a VPC peering connection, and then that instance will be able to connect to the database, and that will be a secure connection, because without making it publicly accessible, we are able to, like, we can make it accessible.
Is there an additional cost for VPC peering?
Yeah, there is an additional cost. There is only data transfer charge. Data transfer across peering connection is charged 0.01 cents per GB for send and transfer, regardless of the availability zone involved. There is no charges for creating the VPC peering connection. Only we are charged for the data transfer. Yeah, which is very cheap if you compare it to. Okay, I'll just create the NAT gateway. Okay, also for Elastic IP, we are only charged for creating Elastic IP if we are not using it. Okay, so if we have created an Elastic IP and if we are not using that Elastic IP, then only we are basically charged for it. If that Elastic IP is in use, then we are not charged for it. Let's say if it is associated with an ad gateway, or if it is associated with a EC2 instance, so then we are not charged for the Elastic IP. If it is not associated, then basically we have to pay an hourly charge for that Elastic IP.
Can you delete an Elastic IP then if you know you're not going to be using one and you don't want to be charged? Can you then?
No, first we need to deassociate it and then we can delete it.
Okay, gotcha.
Okay, now we have two more important concept of in VPC, which is direct connect and site-to-site VPN. Are you familiar with any of these?
Isn't direct connect where there's
Yeah,
like an
direct connect and VPN, site-to-site VPN.
so isn't there an actual like physical cable running from like an on-premise to AWS?
Okay. Yeah, that is direct connect. Okay, now first let us understand what is the need of site-to-site VPN or what is the need of direct connect. Okay. Now, earlier, before AWS, companies used to run their infrastructure on on-premises. Okay, so let's say they want to run their Active Directory server or they want to deploy their any kind of application, internal application which is only accessible to their company network. Okay, like a LAN network, it's only accessible in the company. Okay, it's not accessible outside. I mean, outside we can say it's not accessible over the internet, right? So companies used to have their own data center. They used to set up their own local area network, and with that, basically, they used to make some applications, some internal applications or Active Directory accessible inside the Office network. Those things were only accessible from in the office only. It was not accessible over the internet or in another private network, right? So the same concept basically we have in AWS also. Like we have, let's say this is one AWS region. Okay, and in this region, basically we have some EC2 instances running. Let's say two EC2 instances running, and these EC2 instances are running in the private subnet. Okay, these EC2 instances are running in the private subnet. So we have two EC2 instances running, and these EC2 instances are running in the private subnet. Okay, and now as they are running in the private subnet, they cannot be accessible over the internet, right? They cannot be accessible over the internet, and we only want these to be in the private subnet. Okay, because if we make it in public network, so there are a lot of chances of security issues, right? And there is company like there is on premises, like let's say there is the corporate network. Let's say the company has, let's say, on-prem or corporate network. Okay, so here basically company have a lot of systems on their on-premises, and they have a router. Okay. And what they want to do is they want their employees to access the application which is running in AWS. They have a very big large server which they are running on AWS, and they want with the private IP of the instance, they should be able to access in their machines the application. Okay, let's say it is a web application running and they want to access it, right? Now, currently, if you see, this is not possible because this is running in the private subnet, and if it is running in the private subnet, it cannot be accessible over the internet. There is one way to do it, which is we can use a VPN software. We can install a VPN software in AWS, in one of the instance in AWS, which is running in the public subnet, and through that basically we can do it. Okay, from connecting to that instance we can do it, right? But let's say we want to connect to this instance without any VPN software. So in that case, basically what we do, we set up a site to site, which is also called VPN gateway in AWS. And in this case, basically what we do is like uh, we basically create a connection between the on-premises router. Let's say we connect a connection between the on-premise router and to the VPC. Okay, we establish a connection between the on-premises router and the VPC. Okay, and for this, basically on the on-premise router, we need a special router for that. Okay, like which will be like a Cisco router or Fortnite router or Palo Alto router. Okay, this kind of things, this kind of routers, specialized routers we need on the on-prem side. Okay, like at our home also we have routers. Okay, because of router only we are able to connect to the internet, right? But those routers are not that much, I would say. Those router doesn't have those features. Okay, the on-premise router, I mean, in the corporate, we have Cisco routers or Fortnite routers which are highly configurable. Okay, so only on those routers basically we can set up the VPN with the AWS. Okay, so once the VPN is established, there is a lot of configuration we need to do in the router. Okay, AWS actually give us the configuration, basically a script which we need to execute in the router, and automatically everything is configured. And at the AWS end, we just need to create a VPN gateway. Okay, and once the connection is established, so then these machines will be able to connect to these machines through this, through private IP, through the private IP. Okay, through the private IP, they will be able to connect to that machine. But this connection will be over the internet. Okay, this connection will be over the internet. But these instances will be in the private subnet. They will not be having public IP. They will be having only private IP. Okay, and this connection will be over the internet. So let's say in the console, here we can see virtual private network VPN. So here we have customer gateway. So here we'll be creating a customer gateway. Let's say my on-prem network. Okay, then here we have to provide the public IP address of our on-premises router. Let's say this. Then create customer gateway. Okay, so this IP address will be the on-prem router IP. Then virtual private gateway. This is created at the AWS end. AWS gateway. So we need to create the customer gateway and then the virtual private gateway. And then we need to create the VPN connection. And in the VPS connection, basically we have to choose the virtual private gateway we created and then the on-prem network which we created. And then create VPN connection. Okay, here you can see currently it is set to pending state. And at the on-prem side, we need to download this configuration. Now, depending on your firewall, let's say Barracuda, Checkpoint, Cisco, Fortinet, F5 network. Okay, these are all very popular brands. So depending on our router, we have to download the configuration. Okay, so here you can see this is a configuration file, a script which we have to execute on our router on the on-premises. Okay, and once we do this setup, this status will be set to active, and then the connection will be established. Again, once the connection is established, this instance will be able to talk. These machines on the on-prem will be able to talk to the instance which is running in the private subnet, and vice versa. The instance which is running in the private subnet also will be able to talk with the machines which are running in the on-prem side.
Okay, so when you created the customer gateway, you provided the on-prem router IP, and when you created the virtual private gateway, is that when you added the IP, the private IP for the instance and the subnet that you're connecting to?
No. In virtual private gateway, we don't have to give any IP address.
Okay, yeah, I missed that part. And then you create the VPN connection between the customer gateway and the virtual private gateway. And then once that's created, you go in and you download the configuration. Then you have to add the resulting script to the on-premises router.
Yeah. And the connection is over the internet. Okay. Now another solution which AWS provides is direct connect. Okay, so there is one big advantage of using site-to-site VPN and one disadvantage as well. The advantage is no additional network setup is required. Okay, no additional network setup is required, which means as the connection is over the internet, as it is over the internet, and internet, all the cables and everything is already set up, right? So no additional network setup is required. So this is the advantage, and the disadvantage is as the connection is over the internet, so we don't get enough bandwidth. The bandwidth completely depends upon our internet connection. Okay, bandwidth completely depends upon our internet connection. If our internet provider is providing 100 Mbps download speed and 100 Mbps upload speed, so in that speed only we'll be able to download and upload the data. And if we have a dedicated lease line, so let's say if there we have 10 GB speed, 10 Gbps bandwidth. So we'll be able to send data up to 10 GB within per second, 10 GB per second download and 10 GB per second upload. Okay, but that if we are having a lease line, so that thing basically we have in our hand. But if we have side-to-side VPN, which is over the internet, so that thing is completely managed by the internet service provider. So that is the disadvantage. We can say the disadvantage is of performance. Okay, the bandwidth, basically we have the disadvantage, and that advantage is no additional network setup is required, which is a very big advantage for, let's say, for small companies. Okay, because here we just need a router, that's it. Whereas if we go with let's say, if we talk about direct connect, in direct connect basically we need to, let's say, from the on premises, we have to basically we have to bring the lease line. Okay, lease line is basically a dedicated optical fiber cable. Okay, physical dedicated optical fiber cable which is coming from our router to the to a direct connect location. Okay, here we have the corporate network. And here we have the direct connect location. Okay, the connection is not directly to AWS, it is basically to a direct connect location, and the direct connect location is connected to a AWS data center. Okay, and this direct connect location is connected to the AWS data center. So this will, the connection between the on-prem router to the direct connection location is a physical lease line. Okay, which is basically an optical fiber cable, fiber physical cable. Okay, which is underground, which is like they have to do digging, and that is basically underground to direct connect location, AWS direct connect location. And through the direct connect location, it is connected to the AWS data center. Now here the advantage is we get dedicated network connectivity. Okay, which basically gives a lot of advantages of bandwidth, right? And the disadvantage is, let's say, if your company is located far away from the direct connect location, then basically it is very expensive to set up the lease line for a very big location, let's say of 100 200 kilometers, actually more than that. Okay, also optical fiber cable is very expensive. Okay. And that is, yeah, that is the disadvantage. Also, another, there is one more disadvantage, which is it will be connected to only one data center. Only one data center. Okay, like let's say you want to connect it to Ohio, so it will be only connected to Ohio region. It will not be connected to all the regions. Whereas VPN gateway, side-to-side VPN, you can easily connect it to multiple regions. Multiple regions, it means you have to set up the connection, but you can set up very easily for other regions as well. Whereas the direct connect, if you want to set up for another region, so you have to create the lease line from your company network to the AWS direct connect location. Okay, let's say if your company is in US and you want to set up a network, you want to connect a direct connect location to to the data center in, to the availability zone to the region in UK. So it will be like you have to take, submarine cables and a lot of other things. It has to go through. Okay, which is very expensive. Only big companies like enterprise who are going to use AWS. They only basically use direct connect. Okay. It is expensive, but in terms of performance, it's very fast. And now we'll be talking about load balancing. Load balancing in AWS. We can say elastic load balancer. Okay. Now we are going to talk about elastic load balancers. So in AWS, like first let us see in a scenario. Like in RDS to achieve high availability, we had the concept of multi-user deployment, right? To have the to have high availability to achieve high availability and failover, we have the concept of multi-user deployment in RDS, right? Now the same concept, not the same concept, I would say the same concept we can implement in EC2. Okay, currently in EC2 we don't have any concept of high availability, right? Now let's say if I launch an instance, okay, in this instance, user data, I will add some commands which will be just installing a web server in it. Say bash generate. Okay, systemctl start STPD and enable STPD. Okay, so these are some commands which I want to execute in the instance. I mean, once these commands will be executed in the instance will be acting as a web server. Okay, it will be having web server already installed in it. SSH and Apache HTTP 80. Then launch instance. Currently, we have one problem. Let's say if the instance, let's say this is the instance running, and this instance is running in this availability zone 3A. Now let's say if this availability zone gets down, then so the instance will also get down, right? Or the server rack of this availability zone gets down, so the instance will also get down. And if the instance get down, there will be a downtime, right? If the instance get down, there will be a downtime. Okay, so let's say this is the IP. User data may be still running. Yeah, so the user data script is executed and we are able to see the default page of Apache web server. Now let's say due to some reason if this availability zone gets down, if the availability zone gets down, the instance will also will be down. And let's say if this is our production site, so the site will also get down, right? So overall there will be a downtime, right? Now to overcome this downtime in RDS, what we have a concept of multi-easy deployment, in which if one of the instance server gets down, or if one of the availability zone gets down, there is another instance running in some other availability zone, right? Which is basically a standby instance, right? So the same concept we can implement here. Okay, the same concept we can implement here with elastic load balancers. So in this case, basically what we'll be doing, do you know what is a load balancer in general?
Yeah, I think that you have like several instances that can be used if one fails, or if the traffic is too heavy on one, we'll direct it to the other. Is that correct?
Yeah, it is basically used for distributing the traffic among multiple servers. Okay, and with load balancer, we achieve high availability. Okay, we achieve high availability, and yeah, the main thing basically which we achieve with load balancer is high availability and fault tolerant environment. Okay. So basically, load balancer, like elastic load balancer, is basically a AWS managed service. Okay, AWS managed services means the server is managed by the cloud provider, like RDS is also a AWS managed service, where the database server is managed by the cloud provider. The same way elastic load balancer is also a AWS managed service, where the load balancer is managed by AWS. So here basically what we do, we create a load balancer. Okay, there are several types of load balancers. Okay, so we basically create a load balancer, and behind the load balancer we have multiple EC2 instances running. Okay, there could be one instance also. The standard is like minimum two EC2 instances running, and these EC2 instances should be in a unique availability zone. Let's say US East 1A, US East 1B. Okay, both of them should be in a distinct availability zone, like US East A and US East B. And this we have a load balancer. Now let's say there are 5 users who are connecting to the website. Okay, there are 5 users who are connecting to the application. So what load balancer does is the first request will go to the first server. Second request will go to the second server. Third request. Third request will be going to the again back to the first server. Let's say if we would have one more server, so the third request will go to that third server. Fourth request will go to this server. Fifth request fifth request will go to again to the first server. So what it is doing, it is basically distributing the traffic. It is distributing the traffic among multiple EC2 instances. Another thing is, let's say if this instance get down, so what load balancer will do, it will stop sending the traffic to this instance. Okay, in load balancer we have a concept of health check. So what it will do, it will stop sending the traffic to the instance which is not running or is not healthy. Okay, and it will only send the traffic to the instance which is running. So by this way, there will be no downtime. Okay, for any business application, uptime matters a lot. Okay, for any business application, uptime matters a lot. There should be any company or any organization, they don't want a downtime. Okay, downtime even of a minute. Okay, Let's assume if Amazon.com started having downtime, let's say of 5 minutes, 10 minutes, or let's say an hour, they may lose millions of dollars, right? Because they have that much customer, that much of sales. So for any application, for any business, uptime matters a lot. Okay? The application must be 24/7 up and running, right? So to achieve this, basically we use load balancers. Okay, load balancer also not only gives us high availability, it also distributes the traffic. Okay, so not only one server will be handling all the traffic and get overloaded. Okay, so the traffic is spread across multiple servers. Okay, with which we achieve high availability and a fault tolerant environment. Okay, and these load balancer basically use, this is our load balancer. Okay, currently in general, we are talking about load balancer. Okay, and load balancer basically has load balancing algorithm. Okay, like they have round robin algorithm, least count, IP hash, weighted. Okay, these are all the algorithms. Okay, these are some of the types of load balancing algorithms. Actually, there are more than that, but these are some of the commonly used load balancing algorithms. Now, AWS use out of these, AWS use basically these two algorithms, round robin and least count, and by default it uses round robin algorithm. Okay, and round robin basically what happens? It basically send traffic to, it distributes the traffic like first request to first server, second request to second server, third request to again to first server, fourth request again to the second server. It basically distributes the traffic. Okay, whereas in least count, the server which has the least number of requests, it will be sending traffic to that server. So these two load balancing algorithms are supported in AWS, round robin and least count. This can be asked in the certification exam. Types of load balancing algorithms supported in elastic load balancer. So round robin and least count are supported in elastic load balancer. Now let us talk about types of load balancer in AWS. So in AWS, we have four types of load balancer. We have application load balancer, network load balancer, gateway load balancer, and classic load balancer. Okay, so these are the four types of load balancers we have in AWS. Okay, if we go to console, go here. If we scroll down here under load balancing, we have load balancers. And here we click on create load balancer. So here you can see four types of load balancer. First, we have application load balancer, network load balancer, gateway load balancer, and classic load balancer. Okay. Now let us talk about the difference between these load balancers. First, let us talk about application load balancer. The application load balancer is basically designed for web applications. Okay. With an application load balancer supports HTTP and HTTPS protocol. Okay, it supports HTTP and HTTPS protocol. Okay, it uses it works on layer 7 of OSI model, which is the application layer. Which is the application layer. So application load balancer is designed for running web applications. It works on HTTP and HTTPS protocol. It works on layer 7 of OSI model. And it also, in load balancer, in application load balancer, we can create rules. We can create rules, which is also called path-based routing. Okay, in application load balancer, we can also create rules, which is also called path-based routing. Next we have is network load balancer. Network load balancer is basically used for running any kind of backend service. Backend service like API server. Okay, for this kind of things, basically we use network load balancer, and it supports TCP, UDP, and TLS protocol. Okay, it supports TCP, UDP, and TLS protocol. It works on layer 4 of the OSI model. The layer 4 is transport layer. Okay, layer 4 is transport layer, and it only supports IP targets. Okay, IP target, it means instance IPs. Okay, later when we'll be creating any of the load balancers, at that time I'll show you. I mean, this IP targets and like types of targets we have in the load balancer. So it only supports IP targets, whereas application load balancer supports instance target. Like it supports instance as a target. It also supports lambda as a target. Yeah, it can have multiple targets. It can have not multiple targets. Any of these targets we can put behind the application load balancer. Okay, we can put instance also behind it. We can also put lambda function also behind it. We can also put an IP address behind the load balancer. Okay, whereas in this network load balancer, it only supports instance IP. Next we have is gateway load balancer. It is basically used to run firewall. Okay, firewall or any gateway service, gateway software we can say. Okay, and if we see the protocols, it supports It works on IP protocol, Internet Protocol. Okay, it supports Internet Protocol, and it works on the layer 3 of the OSI model. Layer 3 is network layer. Okay. Okay, do you have any questions here about application network or gateway?
No,
Yeah, here you
question.
can. Sorry?
Application. I do have a
Uh-huh.
question about the application load balancer rules, but I'm thinking that we'll get to that at some point.
Yeah. We'll be creating the load balancer at that time. Yeah. Okay, in the application, yeah, here you can see application load balancer supports HTTP, HTTPS, TCP, network load balancer, TCP, TLS, and UDP, and gateway load balance supports IP protocol, and it's basically more for running firewall or any kind of gateway software, such as Palo Alto firewall. Then we have classic load balancer. Okay, classic load balancer is basically, we can say, a combination of application load balancer and network load balancer. Okay, the reason why we are calling it as a classic load balancer is it was created when this was like when AWS started offering elastic load balancer. So they started with this load balancer. Okay, earlier they only had one load balancer, which was this load balancer, classic load balancer, which supports HTTP, HTTPS, and TCP protocol, which is same as application and network load balancer. Okay, so it has all the features which application and network load balancer has. Okay, but it doesn't have that feature of creating rules, path-based routing. That is not supported in classic load balancer. Okay. Mostly the questions in the certification exam will be related to application load balancer and network load balancer. Gateway load balancer is just introduced last year, and after 20, um, yeah, and in the like AWS basically changed the syllabus in 2020, but they didn't. At that time, this gateway load balancer was not introduced. So mostly the questions will be around application load balancer and network load balancer. One question you'll definitely see of this OSI model. Any of like which of there would be a question like which of the load balancer work on application layer, or which of the load balancer works on the transport layer. Okay, so in transport layer we have network load balancer, and application layer we have the application load balancer. Okay. And in network load layer, we have gateway load balancer. Gateway is, it will not be asked in the certification exam, just for knowledge. And classic load balancer, you may find it like that is very optional. You may find any question related to classic load balancer. It is the like so yeah. So basically, classic load balancer is the combination of application and network load balancer. Okay. Also, in classic load balancer, we don't have to create target group. Okay, what target and in other, in application network and gateway load balancer, we have to create target group. Okay, and what is a target group? In target group, basically we have the targets. Okay, and currently three types of targets are supported. Okay, currently three types of targets are supported. One is instance, Lambda, and IP. These three types of targets are supported in target group. So in target group, basically we add our EC2 instances. Okay, or we can add our Lambda functions. Are you aware about Lambda?
Yes.
Yeah, Lambda is basically the serverless service of AWS. And we can also add IP address. Okay, IP address of our EC2 instances. Okay, of our EC2 instances or any service which we are running outside of AWS also we can route using, we can add the IP address in the target group. So these three targets we can have in target group. Okay, now let us create one load balancer. And before creating the load balancer, we have to create EC2 instances. So let's say we'll be creating two EC2 instances. Let's say load web server 1, and we'll be creating one more web server. So what we'll do is we'll just right click on this, and the server must the instances which are behind the load balancer must be identical. Okay, all the instances must be identical which are running behind the load balancer. Like in terms of data, okay, in terms of data, both the servers must be identical. Okay, in terms of data, both the servers should be identical. So what we'll do is here we have an option. We go all over down. Yeah, image and template. Just we have to right click on the instance, then launch more like this. Okay, and when we click a launch more like this, it will basically choose all the configuration which that instance had. It will be having the same configuration. Configuration, it means like the same instance type, same AMI, same security group, same VPC, same availability zone. Okay, but here we did one small mistake, which is the availability zone must be different. Okay. Okay, it can be same, but in terms of high availability, if our goal is to achieve high availability, fault tolerance, so in that case, basically we create the instances in distant availability zones. And after launching the instance, we cannot change the availability. Okay, and just to do that, let's say I'll just terminate this instance. So we just need to go here, the instance which is running, then launch more like this. And in the network setting, in the step 3 of configure instance, here we'll just change the availability zone. Okay. It seems T2.micro is not available in that availability zone. That is not available, then we can go with T3.micro. Yeah, so now we have two instances running. One is running in 3A and one is running in 3B. Both are running in extend availability zones. So first we have to make our servers ready. Okay, our targets ready. These are basically our targets. Okay, and then we'll go to target groups. Okay, load balancer creation is the last thing. Okay, now we'll be creating the target group. Now here you can see target types. We have instance as a target, IP address as a target, and we have lambda function as a target. So three types of targets are supported in target groups. So in our case, we'll be going with instances. Then here we have to give the target group name. Let's say web servers. Then on which protocol the application is running on. So our application is running on port 80. Then VPC. Then this is basically HTTP version. So if our Apache, our web server is running on any of these protocols, then we can use any of these protocols. Then we have health check. Do you know what is health check?
I think this is where it pings the server to make sure it's still running.
Yeah, exactly. It basically checks whether the application is running or not. And if it is not running, uh, it is like it keeps on trying, it keeps on checking the application. Okay, and if the application is running, then it will basically mark the instances as healthy. And if the application is not running, then it will mark the instance as unhealthy. And if it is unhealthy, then it will not send that, the load balancer will not send traffic to that EC2 instance. And health check path, it completely depends upon the application. Okay. Okay, then we'll add our EC2 instances and create target group. Okay, here you can see two instances are added, but here it is giving us an warning, which it says target group is not configured to receive traffic from the load balancer. So the first step is to create the EC2 instance, then create the target group and add the EC2 instance, and then create the load balancer. So here we'll click on create load balancer. We'll go with application load balancer because we are running a web application. Then the load balancer name. So let's say my application load balancer. Now here we have schema. Schema is basically set of, it is, so here we can say two types of schemas. One is internet facing and one is internal. Internet facing is means it will, if we created internet facing, then it will be accessible over the internet. If we'll be creating it internal, then it will be only accessible inside the VPC network, right? Then it will only be accessible in the VPC network. It is like creating like a private load balancer. If we are creating it with internal, if we are creating it with internet facing, it will be accessible over the internet. Then IP address type, we have two types, IPv4 and dual stack. Dual stack is basically for if you have a VPC with IPv6 network. Then load balancer protocol. So we'll be using HTTP protocol. We can also use HTTPS protocol, which is recommended that we use HTTPS protocol. But for HTTPS, basically we need a SSL certificate. An SSL certificate also we can generate using ACM service of AWS ACM, Amazon Certificate Manager. Okay, through that service, basically we can generate the SSL certificates. Okay, but for that also we need a domain. Okay, because SSL certificates are generated for a domain. So we will go with HTTP protocol. Now VPC. Now here we have to choose minimum two availability zones. Okay, we have to choose minimum two availability zones. Okay, and these availability zones must be same. Okay, I mean in these availability zones only your EC2 instances must be running. Now let's say right now we created one EC2 instance in 3A and one in 3B. So we can go with these two availability zones. But now let's say if you have one instance, if you don't have, and you have one instance running in uh, third availability zone, AP Northeast 3C, and if you are not choosing that availability zone, so in that case, it will not send the traffic to that instance. Okay, load balancer will not send the traffic to that instance. So it is very much important that at the time of creating the load balancer, we choose the right availability zones. Okay, also after creating the load balancer, also we can change it. So right now we have instances running in this availability zone 3A and 3B. So that's why we have chosen these two availability zones. Then it is basically giving us a warning, and the reason is that we are not using the HTTPS listener. And then we'll attach a security group to the load balancer. And here basically it is asking us to choose the target group. So as we have already created the target group, so we'll choose this target group, web server, existing target group. We have already added the EC2 instances in the target group and create. So the load balancer has been created. Okay, and load balancer basically takes some time to provision. It will take 1 or 2 minutes to come in running state. Meanwhile, if we go to our target groups and if we go to targets, so here you can see now they are initializing. Yeah, Tyler, can you hear me?
Yes.
Okay. Okay. So our instances, it is basically giving us an error which is unhealthy. Okay, but we have our instances running. Okay, also in the certification exam, they can also ask the HTTP status code. Okay, right now we are also getting an HTTP error which is 403. So if we go here, we should get 200. By default in load balancer, it basically check for 200 status code. 200 is success. When application is working properly, it basically gives 200. We are getting 403, which is forbidden. The client doesn't have access to write to the content, that is, it is unauthorized, so the server is refusing to give the requested resource. Okay, this error I am seeing for the very first time. Okay, if we go to our load balancer, so our load balancer is in active state, and this is the DNS name through which we can connect to the load balancer. Okay, we are able to connect to the load balancer, and it is also forwarding the traffic to our EC2 instance, but for some reason it is showing here unhealthy. Okay, it is sending the traffic, but it is showing unhealthy. So we can do a deregistration. Deregistration basically means draining the instance. Okay, and at the time of draining the instance, if there is any connection on the instance, that is basically, I mean, the connection will not be revoked directly.
What port are the requests to the servers on? When the health checks are coming through, like what port are they coming through as for the server?
Sorry.
I was just wondering, when the health checks occur from the load balancer and they're coming into the servers, what port does it come in as?
Port 80.
Okay.
It will go to the target group, and target group is listening on port 80.
Okay.
Yeah, and here in the target group, we can see the algorithm, load balancing algorithm it is using. So by default, it is set to a round robin. And we have one more, which is least count. Okay, which in AWS they call least outstanding request. So we have two algorithms in AWS, round robin and least count. Okay. Yeah, it has a deregistration delay of 300 seconds. Okay, as we are draining it, so now it's not sending any traffic. It says 503 service temporary unavailable. Yeah, it's drained. Now we'll again add those EC2 instances. Listening on port 80.
Okay, again it is throwing unhealthy. Okay, it is sending unhealthy, but it is sending the traffic. Hmm. So what we can do is we can change the success code to 403. By default, the success code is 200. We have changed the success code, and now the instances should be healthy. Yeah, now you can see the instances are healthy and we are able to access the application. So basically we are accessing the application not by the instance IP, we are accessing it by the load balancer DNS name, right? And it is accessible over the internet, right? And load balancer is basically sending the traffic to target group, and then target group is sending the traffic to the EC2 instances, right? Now let's say even if we stop one of the EC2 instance, there will be no downtime. Okay, right now I am stopping one EC2 instance. Now only one instance is running, but there will be no downtime. Okay, this is the advantage of using load balancer, with which we basically achieve high availability and fault tolerant environment. Okay, do you have any questions still here?
No.
Yeah, I remember you were asking about the rules, the load balancer rules, application rules.
Oh yeah.
Yes. So here, like in load balancer, if we go to listeners, so here we can see the listeners, like the port on which the load balancer is listening on. So currently it is only listening on 80. We can also make it run on 443, but for that we need the SSL certificate and domain. Okay, now here if we go to rules, so here basically we can create path-based rules. Let's say if, yeah, there are a lot of rules which we can create. Let's say if the source IP is this, or let's say we want to create a redirection rule. Okay, like let's say if, yeah, if host header is, let's say, this domain, which is the load balancer DNS name. So currently the request is HTTP. We want to redirect the request to HTTPS, HTTP to HTTPS redirect. Okay, so that thing we can do using load balancer rules. Okay, not only this, lot of other things we can do. Let's say if the request is coming from some specific country, so we can also forward it to some other target group. Let's say we create a target group, let's say for the servers in UK, and if the request is coming from this, let's say this network. Let's say the IP is coming from this network. The request is coming from this network. Then forward the traffic to, let's say, the servers in UK. Okay, it may be having, the application may be having some different language. Okay, that thing we can do using these rules. A lot of good things basically we can do with these rules. Okay, we can also do path-based routing. If let's say if the path is / about us, then send it to some other target group. Okay, these kind of things basically we can do using target groups. Sorry, application load balancer rules. Okay, currently it is showing not found URL because it actually doesn't exist on the server. That's why it is basically showing as not found. About us. Yeah, so this kind of rules basically we can create in the load balancer. And this is only supported in application load balancer. Okay, actually, in the load balancer, we added one rule, which is forwarding it to redirecting to it to HTTPS, and we don't have the SSL. That's why it's basically giving the error. Okay, do you have any question in load balancer now?
Is the interface that you're using, is that, I recall a different interface when I've worked with
Sorry?
past. As far as the interface that you used to create it,
Uh-huh.
did you have to do anything special to get that interface?
Yeah, we have to go here, view/edit rules.
Oh no, I meant the general creation of the load balancer.
Yeah, we have to go here, create load balancer. Then
Yeah.
here.
It just looks so different.
At your end?
Yeah.
Really? Yeah. Can you show? I mean, can you share your screen? Maybe.
No, I'm not looking at it right now. I'm just in the past when I've worked
Yeah,
with.
yeah. Actually, the UI they have changed. I mean, the UI of this AWS console they have changed. Here you can see new EC2 experience. Now, let's say if I disable this. Yeah, now it will go to the old school. Maybe not this one, but here you can see target groups. Yeah, it looks like very old. I mean,
Hmm.
yeah.
Okay. Gotcha.
Yeah, that is just the UI change they have made.
Okay.
Sorry. Sorry. Okay, so we have two EC2 instances running, and we have a load balancer running, and it is basically routing the traffic. Okay, now what we want to do is, basically we want to achieve okay, so we want to basically scale up the servers. Okay, let's say if there would be a lot of traffic on the servers, so we want to scale up the servers. Okay, let's say if there is like thousands of people connecting to the server, thousands of requests going to the server in every 1 minute. Okay, so in that case, it will not be able to handle the traffic. Okay, just to simulate this, I'll just do one thing. Okay, currently if I do refresh, so I'm able to see the application. Okay, I'm just going to run one load testing on the server, which will actually use all the resources of the of the EC2 instance. Okay, I'm just going to send like a this is K6 is basically a load testing software through which basically we can perform load testing, and in this load testing basically it sends a lot of requests to the server. Okay, so now if I refresh, so here you can see it is taking some time to respond. Earlier when there was no load, so it was not taking just within a second it was I mean we were able to see the page, but now we are not able to see it. Okay, because currently I have sent around like 1,000 requests on the server. Okay, more than actually, yeah, 1,000 requests, and it is basically sending. It is going to send for 30 minutes. And if we go to our EC2 instance, the CPU utilization of our EC2 instance will go more than, it will go above 90-95%. Okay, currently it is not showing, and the reason is because we have basic monitoring enabled on the EC2 instance, and with basic monitoring we only get the data every 5 minutes. Okay, so we'll just enable enhanced monitoring, sorry, detailed monitoring. Same on this instance as well. Okay, so anyway, it is basically taking time to respond the request, to reply the request, to get a response from the server because of lot of load on the instance, lot of load on the EC2 instance. Actually, if we log into the EC2 instance, we'll be able to see the load. Okay, here you can see the CPU is almost running on 100. Maybe the request is completed. Yeah, so if there will be a lot of requests on the server, so there will be a lot of load on the server. Okay, and if there will be a lot of load, so we already saw, I mean, the response, I mean, it was taking time to respond. Here you can see it is still taking time to response. Okay, we are not getting a response from the server. It is giving, but it is basically taking 2-3 seconds to give the response. Okay, now to overcome this, basically we have, yeah, let's say there will be a lot of response time, so that will result in bad user experience, right? So in that case, basically AWS has a concept of auto scaling. Okay, so with auto scaling, what we can do is, in auto scaling, basically we create auto scaling policy. Not auto scaling policy, we can say it as scaling policy. Okay, we can create a scaling policy. And with the scaling policy, what we can do is, okay, we can create a scaling policy, and with the scaling policy, we can create a threshold. Like if the average CPU utilization of the target group, or we can say of the targets running in the target group, goes beyond 70%, or let's say 70%, then add more instances. Okay, then add more instances. So when we create the auto scaling, so in auto scaling, basically we create auto scaling group. Okay, and in the auto scaling group, basically we basically set 3 values. One is desired, one is minimum, and one is maximum. So desired is like how many instances should be running in the target group. Okay, like when we create the auto scaling group, so basically we associate this auto scaling group to a target group. Okay, so here basically we set a number, like how many instances should be always running inside the auto scaling group. So we want 2 instances to always be running in the auto scaling group, and minimum we want 2 instances, and maximum we want 4 instances. Okay, maximum 4 instances. This will happen if this threshold is crossed. If this threshold is crossed, then it will launch 2 more instances. Okay, if the CPU utilization of 2 instances, of 2 instances are beyond 70%, average the CPU utilization of both the instances are beyond 70%, then it will, what it will do, it will deploy 2 more EC2 instances. Okay, to handle the traffic. Plus, it will also send us a notification through SNS service of AWS. It will send us a notification to the server admin or the account admin that the threshold has been crossed and AWS has launched 2 more EC2 instances, and those EC2 instances it will launch, and it will add those EC2 instances inside the target group. Okay, and all these things are automated. We don't have to do anything manual. Okay, all of these things are automated. We don't have to do anything manually. AWS will automatically check the CPU utilization, and how it basically checks the CPU utilization, it basically checks from the CloudWatch. It basically checks if the CPU utilization is more than 70%, then it will automatically set the number of instances to max number of instances. It can be 4, it can be 10, it can be 20. Okay, depending on the use case or depending on what kind of workloads we are running. Okay, and we can integrate it with SNS service, and with SNS is basically a service of AWS which is used for sending notifications. Okay, which is used for sending notification, or we can say for alerting. Okay, so when we create auto scaling group, we basically set these information. We choose which target group we want to configure it for, what should be the number of instances, what will be the scaling policy, and we also do one more thing, which is we have to associate a launch template or launch configuration. Okay, we need to associate a launch template or a launch configuration. Okay, so what is launch template or launch configuration? Launch template basically has the configuration of the instance. Okay, it basically has the configuration of the instance. Configuration of the instance which will be launched by auto scaling group. Auto scaling group when the threshold is crossed, or that the target group doesn't have the minimum number of instances running. Oh, sorry, doesn't have the desired number of instances running. Okay. Do you have any questions still here? Launch configuration is, I would say, deprecated. Okay, it is still there, but it is deprecated. Okay, currently we use launch template, which is yeah, which was added almost, I would say, 2 years back, and is more useful, I mean, as compared to launch configuration. Launch configuration we can only use with auto scaling. If we talk about differences for launch configuration, we can only use with auto scaling, whereas launch template we can use with EC2 instances also, and we can use it for with auto scaling also.
Do you have to set up the launch template yourself, or is that set up for you based on the instances that are already there?
Yeah, we need to manually create it. We need to create the launch template. And in the launch template, we all for that also we need to create a AMI also, AMI of our current application.
Okay.
Yeah. All right. So okay, so we were talking about auto scaling, and okay, we talked about auto scaling group. Okay, so in auto scaling group, to get started with auto scaling, first we need to create an AMI of any of these instance, because the instance which will be launched through our auto scaling group must have the same data. Okay. So first we'll be creating an AMI. Let's say ASG image. Then create. Okay, so we have requested the image. Okay, once the image is created, then we'll be creating a launch template. So first we need to give the template name. Let's say my launch template. Then this thing will keep it as default. Yeah, then we have to choose the AMI. So here we will be choosing the AMI which we created. Yeah, this was the AMI which we created. Then instance type we have to choose. So let's say you want to launch t2.micro instance. Then key pair which will be associated. Then VPC, in which VPC we want to launch. And here we have to make sure the VPC is same as, sorry, not the VPC, we have to choose the security group. Yeah, so here we have to make sure the security group is same, which we are using in our EC2 instances, I mean, which are running in the target group. So those instances are using WebSD. We are using the same security group. Okay, because security group here will determine the VPC. Okay, other things we'll keep it as default. Yeah, other things we'll keep it as default. Then create launch template. Okay, so first what we did, we created the AMI. The AMI is in available state. Then we created the launch template, and this launch template we are going to use with our auto scaling group. Okay, so in auto scaling, basically first either we need to create a launch template or launch configuration. Okay, launch configuration is, I would say, now deprecated. Okay, and launch template has much more features as compared to launch template. In my auto scaling group. So first we need to give the name. then we have to choose either the launch template or launch configuration. So here we'll choose our launch template which we created, or if we have a launch configuration, so here we need to click to switch to launch configuration. We have to choose the launch configuration. So we'll go with launch template. Okay, here you can see the AMI which it is using, the key pair it is going to use, the security group it is going to use, what's the launch template ID, the instance type. Okay, and we can also set it to spot instances. Like let's say we want to, when the auto scaling is going to happen, we want to launch spot instances. Okay, so that also we can do. Okay, here we can set the distribution. Let's say we want 50% spot instances and 50% on-demand instances. So these things basically we can set. Okay, or we can also go with adhere to launch template. So in launch template, currently we have set it to the design, I mean, to the on-demand instance. So it will launch the on-demand instance where we'll be having the hourly price. But it is recommended that if we'll be having, let's say, less traffic on the application, I mean, traffic not for a longer period of time. Okay, let's say in Amazon we have sale like Big Billion Day sale, a lot of other sale, let's say Christmas sale. So there is a lot of traffic for, let's say, for 2-3 days, right? And the sale days, there is a lot of traffic, right? So if it is for 2-3 days, then it is recommended to go with on-demand instance. And if the traffic will be only for 1 or 2 hours, then we can go with spot instances. Because of spot instances, we are not sure the pricing. Okay, pricing can change anytime, and AWS will request us to take action. I mean, to continue running the instance with the new price or to terminate it. Okay. Okay, then in which VPC we want to launch the instance? So VPC must be the same where our current EC2 instances are running, and in which subnet we want to launch. So we'll be choosing these two subnets in which our load balancer is created. Okay. Then we have to click this option, which is the second option, which says attach to an existing load balancer. Because we already have a load balancer, then here we have to choose the target group in which it will add the instances. Then here we have two types of health checks. One is EC2 health check and one is ELB health check, which is the target group health check. So by default, EC2 health check is enabled, which basically checks whether the instance status is healthy or not. If the instance status check fails, then it basically launches a new EC2 instance. And we can also enable ELB health checks. Okay, if the instance get unhealthy, so it will launch a new EC2 instance. Now here basically we are setting the group size, like how many instances we need. Let's say we need 2 instances, minimum also we need 2 instances, and maximum we need 4 instances. Okay, and this maximum, like when this group will be created, it will be having 2 instances. Okay, and when the threshold will be crossed, let's say here we are going to create the scaling policy. CPU utilization policy. Yeah, so here we can set average CPU utilization, average network input output, application request count per. So based on that, basically we can set the threshold. So let's say if the CPU utilization, usually we configure it for 70-80%, and if it is for consecutive for 300 seconds, then it will launch a new EC2 instance. And we can also enable this feature, which is enable instance scale-in protection, which basically what it will do is, if we have on our EC2 instance, we have termination protection. So it will, if we enable this option, so it will disable the termination protection and terminate the instance. Okay, if uh, in case of scaling down. Okay, so basically with auto scaling, we can scale up also and scale down also. If the workload gets down, if the CPU utilization is back to normal, which is 20 to 30%, so it will automatically scale down also. I mean, it will scale down to 2 instances. Okay, so it will automatically scale up also and scale down also. The next, and here we can add a notification. So for this, basically, we need to create a SNS topic. Let's say auto scaling. Then email. Let's say email of the AWS account admin or the server admin, who is basically taking care of the instance, and what kind of events we want the notification for. Let's say for launching an instance, terminating an instance, failed to launch, failed to terminate. Next, and create ASD. Okay, so what it is going to do is, it is going to launch 2 EC2 instances, and it will terminate the old 2 EC2 instances. Okay, also we can do one more thing. Let's say if we have existing workloads, so we can actually add them to auto scaling group. So it will not terminate these instances. Okay, currently it is showing 4 instances. We go to auto scaling group. So it is showing desired capacity as 4. But desired capacity, we set it to 2. Okay, so we have set the desired capacity as 2, minimum instance is 2, and maximum 4. And what it will be doing, it will be launching an instance using this launch template. Okay, also if we go to auto scaling, automatic scaling, so this is the scaling policy which is set. If the CPU utilization is more than 70%, so the action what it is going to take, or add or remove capacity units as required.
Is there a way to set a threshold latency, I guess, where like you have to be over 70% for a certain amount of time before another one will spin up?
Yes, we are setting that time, let's say for 300 seconds.
Oh, okay.
If the CPU utilization is for 70% for 300 seconds warm up time.
Okay.
Yeah, 300 seconds to warm up before including in metric. Yeah, so it will automatically launch the instance, plus it will automatically add inside the target group as well. Yeah, it has added all the instances in the target group. Okay, and just to test auto scaling, let's say if we terminate all the 4 instances. So what, let's say if we terminate these instances. So what auto scaling is going to do is it will always ensure that minimum 2 instances are running. Like the desired capacity we have set to 2 instances. Even if we stop these EC2 instances, it will automatically launch 2 EC2 instances. It will always make sure that at least 2 EC2 instances are running, and always those 2 EC2 instances are healthy in target group. If it will not be healthy, so it will keep on launching the EC2 instances unless it becomes healthy.
So if only one were running, then only one would spin up because we're trying to meet that desired capacity of 2, right?
Yeah, exactly.
Okay.
Okay, do you have any question on auto scaling?
No.
Yeah, in auto scaling, there will be question more related to scaling policy, launch template, and there would be some scenario-based questions like which will be like they will give a company is trying to host application, and there will be a sale on the on the I mean on the website on, let's say, on the weekends. So what service of AWS should be used to um, ensure there are enough resources to handle the traffic. So these kind of scenario questions basically they will be giving more in auto scaling. Actually, if you'll go through the book, you will find a lot of good questions actually, scenario based questions, and yeah, like a lot of good questions are there.
Cool.
So after this training, you're planning to sit for the certification exam.
Yeah, so I do need to schedule. I do need to, I guess, spend some more time going through, because when I've taken some of the practice exams, I haven't reached that like 80%. So I do need to spend some more time. And plus, it seems like it would take a long time to get through the material in that book.
No, that is more in depth, like it's more good for like in-depth knowledge. Plus, it is like if you want to sit for interviews, that it will help a lot. That book actually.
Okay.
You're currently working or?
Yes. So I'm full-time web developer, and just really interested in cloud computing. But I also, started from not knowing anything about cloud computing at all, and then I sat for the cloud practitioner and passed that one. And this is like my next step, is trying to get a little more depth into the material.
Which web technologies do you work on?
As far as the AWS technologies?
No. I mean in your web development.
Oh,
front end or back end?
well, I do full stack, but it's mostly been front end with some back end here and there.
Okay, in back end, which language do you use?
So Node, and we work with Angular, so we've been using the Nest framework. That's been mostly it.
Because you want to go to, you want to switch to more DevOps role.
Yeah, I just want to learn more about it. I'm really interested in it, and I just don't really know anything about it, but I'm starting to learn more, and I think it's really interesting. And yeah, I still want to be, a developer, but I would like to, take on some of those DevOps roles. But I think it seems like it's just so much to know that it takes a long time to really, be able to practice DevOps exclusively.
Yeah, so every time when it will be launching an instance through the auto scaling group, it will be sending an email. I just received an email. Yeah, termination and launch for group. Yeah, so let's say it launched an EC2 instance. So yeah, here it is basically giving the instance ID and in which subnet, which availability zone it has launched the EC2 instance. Yeah, increasing the capacity, the status of auto scaling. Yeah, because we created the SNS topic at the time of creating the auto scaling.
There's is there like a little bit of downtime, or is it pretty instantaneous?
Yeah, there would be some downtime, but yeah, actually, right now I have simulated it. Like I terminated the EC2 instances manually, all the 4 instances manually. So there will be some downtime, which will be almost of around 5 minutes. If someone is doing manually, like terminating all the instances which are running in the auto scaling group. But if it is naturally, like there's a lot of traffic, or if one of the availability zone fails or something like that, so there will be no downtime in that case. because we will be having instances running in multiple availability zones. So there will be less chances of failure. Yeah, so it has launched for the instances. Okay, now we'll be starting with the S3 service of AWS. Do you have any questions in load balancer auto scaling?
No.
Have you started going through the book or any questions?
Yeah, I was looking at it yesterday. I just received it on Friday, so I started looking at it yesterday. No, I don't have any questions yet. I was just looking through like the certification. I'm sorry, the like initial assessment questions and going through the answers and kind of learning more about the ones that I got wrong. So that's kind of where I'm at with that.
Mm-hmm. Okay. Do you have any idea about S3?
Yes. So yeah, simple storage service, and you can store data. You can store files for a static website, and you can set life cycle policies just to decide how long you want to keep data.
Mm-hmm. Okay. First, we'll talk about types of storages. Okay, so basically we have three types of storage: block storage, file storage, and object storage. So now depending, and all these storage types is basically the end goal of these storage is basically to store the data, right? But depending on our use case, we can, depending on our use case, basically we use, any of these types of storage. So let's say if we want to run a operating if you want to run a EC2 instance. Okay. So for that, basically we need a block storage. Okay. What is block storage? Block storage is basically a raw disk. Okay, it is a raw disk in which basically we install operating system. Okay, mostly it is used for operating system, like for installing the operating system. Okay, and in AWS we have a service which is EBS, which is the block storage, elastic block storage service of AWS. Right, and yeah, so it's basically a raw disk, and that disk basically we install operating system. Raw disk basically means it doesn't have any file system, no data is there. It's just an empty disk with no file system. Okay, okay, and this block storage can only be attached to one server at a time. Okay, let's say we have two EC2 instances. Okay, let's say we have two EC2 instances and we have one EBS volume. So this EBS volume we can only attach to one instance at a time. We cannot attach to two instances at a time. Okay, it can only be attached to one instance at a time. Okay, and the use case of using block storage is mostly for like for operating system. Okay, for installing operating system or having it as a boot volume. Then we have file storage. In AWS we have a service which is EFS. It stands for Elastic File System. Okay, and file storage, if we see examples, so we have NFS server, which stands for network file sharing, which is very popular actually in Linux. And we have Samba in Windows, which is also called SNMB, through which basically we, like in Windows, we create a folder, and through which basically we can share the folder across a network, right? Across a network, with this across a network, we can share the data. Okay, so file storage, in file storage we have file system. Okay, it's not a raw disk, it has a file system and it is mounted on a server. Okay, also it can be, okay, we can call it as it is a shared file system. Shared file system, it means it can be mounted across multiple EC2 instances. So let's say when we create a file storage, so this file storage can be attached to multiple EC2 instances. Let's say this is the file storage and we have two EC2 instances running. So this file storage can be attached to multiple EC2 instances. We can also attach to 10 EC2 instances. Okay, but EBS can only be attached to one instance at a time. Okay, block storage, the main use of block storage is for operating system. Okay, for using it as a OS disk or boot volume. Okay, usually we do not use block storage for storing data. Okay, on servers we do not use block storage for storing the data. Okay, we can use it, but usually we do not use. Okay, actually block storage is not meant for storing data. It's more for operating system and yeah, that boot volume, it's basically more for that. Whereas file storage, in file storage we cannot install an operating system. Okay, in file storage we cannot install a operating system. We cannot use it to spin up a server. We cannot use it as a disk to spin up a server. Okay, so the advantage of using file storage is it can be mounted on multiple EC2 instances, or we can say multiple servers. Okay. Okay, this is the main advantage of using file storage. And this storage is basically used for storing data. Okay, file storage is the main goal of file storage is to store the data. Okay, store the data, and the data which you want to make accessible to multiple clients. Multiple clients mean multiple servers. Okay, so in that case, basically we use file storage. Now the third type of storage which we have is object storage. Okay, in AWS for object storage we have S3, which stands for Simple Storage Service. Okay, object storage is the combination of block storage and file storage. Okay, and file storage is the combination of block storage. Okay, so when we are creating a file storage, we are actually using block storage. On a block storage, first we will be creating a EBS volume, and that EBS volume we will be sharing it as a file storage. We'll install the file system, and then we will be sharing that storage using NFS or Samba to make it as a file storage. Same way, object storage. So to create object storage, first we have to create file storage. And to create file storage, we need to create block storage. Okay, it is like we have a raw disk, and on top of that disk we are running NFS, the file storage, and on top of that we are running the object storage. Okay, so file storage is completely dependent on block storage, and object storage is dependent on both file storage and block storage because it runs on top of block and file storage. And each of these file systems, basically it completely depends upon the use case. It completely depends upon the use case, and each of these file systems have their own advantages and limitations. Okay, like if we see block storage we cannot mount across multiple EC2 instances, whereas file storage we can attach to multiple EC2 instances. We can share it to multiple EC2 instances. If we talk about limitations and in file storage, so the limitation is we cannot use it for spinning up servers. Okay, we cannot use it as a raw disk to spin up EC2 servers. Now if we talk about object storage, so in object storage basically it uses API based access. The access is API based. We basically use HTTP methods like put, post, delete, get to upload, download the data, upload, download, delete the data. Okay, so here object storage is very fast as compared to file storage and block storage. And here basically the data is stored inside the disk only. Like when we store the data, Okay, so when we store the data in, let's say, simple, I mean, in any object storage. So when we store the data, let's say in the disk. So what it basically does is, currently, if we store any data in our disk, let's say in our laptop, in our desktop, and when we search for a file, so it basically search the whole computer for that file, right? But in object storage, what it does is, it basically stores the path of the object in the RAM. Okay, and RAM is very fast as compared to the disk storage. Okay, it is very fast. So instead of searching it inside the disk, it basically searches in the RAM, and in the RAM basically we have the file location, file path, and then basically it points directly to the file. So instead of performing a search, it basically directly downloads the file. Okay, so the data retrieval in S3 is, or in object storage, is very fast as compared to block storage, file storage, and object storage. Okay, now if we talk about pricing, so S3, or I mean, yeah, if we talk in terms of AWS, so S3 is the cheapest storage service of AWS. Okay, S3 is the cheapest. Okay, then we have block storage. Block storage is cheap as compared to file storage. Okay, this comparison basically we are doing in terms of AWS. And file storage is the, I would say, the most expensive as compared to block and object storage. Okay, because here AWS is basically offering EFS service, and EFS is basically a AWS managed service, where the underlying hardware, the server, everything is managed by AWS. Okay, and in EFS we can store data up to exabytes. Okay, a lot of data basically we can store in EFS.
So it's the most expensive, but the advantages are the fact that it is managed by AWS and it can store the most data.
Yeah, it can store a lot of data. It is managed by AWS. Plus, it can be used to attach. It can be used to attach to multiple EC2 instances. It is very useful in case of load balancer. Okay, let's say we have a load balancer with two EC2 instances. Now, let's say if this user is uploading some data, so the data will be stored inside this instance, right? But let's say the next time the user tries to log into the application, now this time let's say his request goes to this server. So in this server, his data will not be found because the data is stored in this server, right? So to solve this, basically we use EFS file system. So basically we create a EFS file system and we mount this file system to EC2 instances. So then what we do is, any data which will be stored, created by this user, instead of storing inside the EC2, we store it inside the file system. So it is accessible to, centrally it is accessible to all the instances.
So this could also be achieved via API, but then you'd have to manage that, right?
API.
Like, couldn't both servers hit the S3 bucket? And
Yeah, that also we can do. Yeah, static files like images, those things we can do that. Yeah, but there would be like some development requirement, like we need to use the AWS SDK to do that software development kit of AWS to integrate it with S3. Have you used SDK, AWS SDK?
Not really.
Yeah, they have SDKs for JavaScript, and I think for Node.js also they
And that's just like, would that be kind of like a package that you would add to
Yeah,
your?
it is just like a module. Yeah,
Yeah. Okay.
S3 module. Yeah, npm package we can. Okay, S3 is a very cheap service of AWS for storing data, and it is actually used by many companies uh, as their storage solution. Okay, like companies like Netflix, Capital One. Okay, a lot of big companies basically use S3. Okay, because it is cheap, as well as I mean everything is, I mean, the underlying infrastructure is managed by AWS. Okay, so no, they don't have to manage any hardware, and they are getting cheap storage. Okay, so in S3, basically S3 is more similar to Google Drive. Okay, in Google Drive also what we do, we basically create an account, and in Google Drive basically we start storing our data. Okay, any kind of data, basically we can store image, videos, PDF, documents, right? So the same thing we do in S3 also. In S3 basically we create a bucket. Okay, like in Google Drive, basically what we do, we when we create, we sign up for Google Drive, we are basically creating a drive, right? So the same way in S3 basically what we do, we create a bucket. Okay, bucket is equivalent to drive. Okay, drive, or we can say a disk. And in this disk basically or in this drive we basically store our data. Okay, and this data we call, in S3 language we call it as objects. Okay, so in AWS what we are doing, we are creating a bucket, and inside that bucket basically we store our objects. Okay, an object is nothing but the data. Okay, any kind of data like image, mp3 file, mp4 files, documents, right? So that is basically the object. In the S3 language basically we call it as a object. Okay, so if we go in services, so under storage we will find S3. Okay, now here we'll click on create bucket. Okay, and the bucket name must be globally unique. Okay, there is actually a reason, because of that the name should be globally unique. As we move forward, I'll show you the reason why why the bucket name must be unique. And also S3 is a global service. Okay, This is the second service which we are learning, which is a global service. Like we learned about IAM. IAM is also a global service. S3 is also a global service. And there are two more services which we will be learning. One is Route 53 and one is CloudFront, which is a global service. Okay, this question is also asked in the certification exam. Like they will give a couple of service names and we have to basically choose which of this service is a global service. So 4 services in solution architect certification exam are global service, IAM, S3, Route 53 and CloudFront. Okay, so here the bucket name must be unique. So here will be, and the way to create, I mean, like it should be unique. So let's say if I try to create by this name AWS, so I'll not be able to create. So it says this name is already in use. Now let's say I want to create the bucket name, but I'm not sure which bucket name is in use or not in use. Okay, so what we can do is, what companies basically do is, let's say they want to create a bucket for their production environment, or let's say for a project. Let's say project A. Okay, they want to create a bucket for project A. So they will give this name and then the account ID. Account ID is globally unique, right? So like this, project A and the account ID. So this will always create the bucket, give a unique bucket name. Okay. Then we have to choose the region. Okay, S3 is a global service, but still we have to choose the region, right? So we have to choose the region in which we want to create this S3 bucket. So let's say we want to create in Northern Virginia. Okay, then this is basically more related to security. Later we'll be talking about this. Bucket versioning, that is the property of the of the S3 bucket, that also we'll talk later. Encryption also we'll talk later. So we'll just click on create bucket. Yeah, so this is the bucket which we created, project A and the account ID. Now in this bucket, we can store any kind of data. Any kind of file we can upload to this bucket. Let's say I want to upload this image. Let's say a document file, a PDF file, Excel access file, a PNG, a tar file. Okay. We can also add a folder as well. Let's say we want to upload this full folder. And then upload. So it will upload all the files. Okay. Now there is a limit. Sorry.
Is there any restrictions on the type of files that can be uploaded, or can it be like any type of file?
Any kind of file we can upload.
Okay.
Yeah, also there is a limit, like from the console we can only upload a file of, we cannot upload a file more than 150 GB. Okay, if the file size is more than 150 GB, then we cannot upload by the AWS console. For that, we need to use the AWS CLI. Sorry, it is 160 GB. 150 GB was earlier. It is 160 GB through the console. If we want to upload a file more than 160 GB, then we have to use the AWS CLI. So currently we are just uploading 66 MB. Okay, also in a AWS account, we can create up to 100 S3 buckets. Okay, we can create up to 100 S3 buckets. That is the soft limit. We can request AWS to increase the number of buckets. But by default, we can create up to 100 S3 buckets.
You said 100?
100, yeah, 100.
And that's per account?
Yes.
Okay.
Object upload limit y console is 160 GB and max upload size is 5 TB. Oops, 5 TB, which means we cannot upload a file more than 5 TB. If we have a file of 5 terabytes, so we cannot upload that file to S3 bucket. Okay, so that is the max upload file size. Okay, so the files have been uploaded. Okay, now let's say this is the file. Yeah, WPS Office logo full.png, and this is the object URL. Okay, so the reason we call S3 as a global service is, if we see this object URL, okay, in the certification exam there will be questions related to object URL as well. Let's say if you have uploaded image or any file inside your S3 bucket, so what will be the object URL of that file? So they will give you some some URLs like this. Okay, so here basically if we see, the first thing which we have is the bucket name. Okay, then S3 Amazon, s3.amazon.com, that is the, like, S3 is the service name, and that Amazon AWS is just the domain, and then we have the object name. Okay, before object name we have the prefix and then the object name. Okay, so this is the bucket name, and this is the reason why we call S3 as a global service, because when we create the bucket, it basically creates a domain with that bucket name. So practically it is impossible to create like a domain by the same name. Okay, like if we are, let's say I have created a bucket by this name, and if someone else has created the bucket by the same name, so the name of the bucket, that will overlap, right? And the way AWS is trying to create the bucket name, I mean the object URL, is basically they add the bucket name, right? So hence basically we call S3 as a global service because of this reason only. Then we have the domain name, which is S3 Amazon. Then we have prefix. Okay, what is prefix? Prefix is, we can call it as the folder name. Okay, let's say in our local machine, we create folders, right? So in S3, when we create folder, so that folder basically we call it as a prefix. Okay, let's say we went to this folder downloads. So downloads will be a prefix. And then if I go to another, let's say another folder, AWS, so the prefix will be downloads, then AWS. Okay, so yeah, so the folder name or the directory name, basically here we call it as a prefix. And at the last we have the object name.
And you can name your object something different than your file name, right?
Yeah.
Okay. But otherwise the default is just going to be the file name.
Sorry?
The object name by default is going to be the file name, right?
Exactly. Yeah. The object which we have uploaded to the S3 bucket. Okay, now let's say we uploaded an image, and if we try to access this image by the object URL over the internet, let's say we want to use this image in our application. So currently it is giving us an error which says access denied. And the reason of this access denied is permission error. Okay. So in S3 is basically very secure as well. Okay, there is basically 3 layers of security in S3. Okay, so this is our AWS account, and in our AWS account we have a S3 bucket. And inside this S3 bucket we have an object. Okay, so now what we want to do is, like, as a end user, what I'm trying to do is I'm trying to access an object which is stored inside the S3 bucket. Let's say this is an object which is stored inside the S3 bucket, and as an end user I'm trying to access it by the object URL, and I'm getting access denied, right? Okay, and the reason is because of the 3 layers of security of S3. Okay, so the first level of security is account security. Okay, so first layer of security is account security. Then we have bucket level security. and then we have object level security. Okay, so these are the three layers of security. One is at the account level, one is at the bucket level, and one is at the object level. Okay, and object level is at for individual objects also. For individual object, there is basically uh, security. It's not globally for all objects. For individual objects, we can set. I mean, there is a security by default. Now, to access this object, we have to bypass or we have to disable these three levels of security. Okay. So first, let us see the account security. So if we go here, yeah. So if we go here and if we go to okay, and if we go to yeah, block public access setting for this account. So this is basically the account setting, and currently it is disabled. Okay, if you have set up a fresh AWS account, so you'll find this setting as enabled. Okay, you will find this setting as enabled. So this is account level security. So by default, like for a fresh AWS account, you'll find this enabled. So first we have to disable this security. So this is a global security for all the buckets and all the objects. So first we are disabling this. Now the second layer of security we have is bucket level security. If we go to this bucket, then if we go to permissions, so here we have bucket settings. So by default, this is also enabled. Okay, so we need to first disable this. Then if we go to objects, so let's say this is the object. Now, but still if we see, we are not able to access the image, right? So we have disabled the account level security, object bucket level security. Now we need to disable the object level security. So let's say we want to make this image accessible. So we'll click on that image, then we'll click on object action and make public. And once we do that, now we are able to see the image, right? We are able to see this image. Okay, but if we see the same object which is stored inside the bucket, let's say some other image, Okay, so we just uploaded an image, and if we try to access this image through the object URL, we'll not be able to access it. Okay, so for individual objects, we need to disable the security. Right now, let's say we need to, if we make it public, now we'll be able to access it. Now, let's say if I enable the account level security, if I enable this one, so what it will do, it will overall block all the access. Okay, I just enabled it, and this file will not be no longer accessible, and this file also will not be accessible. So if any of this layer has security enabled, so the access will be denied. Okay. Okay, so S3 buckets basically we can use for, let's say in terms of application, we can use for storing any static files like images, CSS files, JavaScript files, and we can also use it for, let's say if the application is a e-commerce application, so we can use it for storing the images. Also, we can use it if the application is, let's say, a e-learning platform, so we can use it for storing videos. Okay. Okay, now let us talk about the properties in S3.
Oh, I wanted to ask,
Mm-hmm.
other than the option of leaving, your object just wide open and completely blocking it, is there any, what are your in-between options?
Sorry.
So it seems like the only two options are it's either completely open or completely blocked, right?
Yeah.
Is there
Not completely open. Not completely open. Like completely. Yeah. Actually, each of the individual bucket has its own security. Okay. By default, all are blocked. Okay. If we enable in one of the bucket, it will be only applied to that bucket only. Plus, at the object level also we have the security. Even if we make the bucket public, if we disable the security, then also the objects are not publicly accessible. Also, we can restrict the access using bucket policy also. Let's say we only want the data to be accessed from a particular domain or from a particular IP address. So those things also we can do using bucket policy.
Okay, cool. So for you have a CloudFront distribution and you want it to be accessed that way, that would be in your bucket policy.
Yeah. That also we can do. In that case, we use the OAI policy of CloudFront to restrict the access. Yeah, and it's more for caching the content, caching the data which we are storing in S3 bucket to be accessible to be accessible through the application anywhere in the world, actually. Anywhere in the world, I mean, like let's say if we are storing the data inside the S3 bucket, let's say we have stored in Virginia. If we are using CloudFront, so if we are stored in Virginia and someone from Australia or some other country is trying to download, so it will take some time to download. Okay, the download time will be like it may take let's say we want to download a 100 MB file, it may take 1 or 2 minutes for someone who is sitting in Australia or UK or some other place. And if we are using CloudFront, and if we have created the CloudFront distribution as a with the global caching, okay. Now let's say if someone tries to download the same 100 MB file, so it will just take 5-10 seconds to download it. Because what CloudFront does, it basically creates the cache of the file in all the edge locations. Okay, so it will create the file, the cache of the file, a replica of the file in the nearest, in all the edge locations. So instead of downloading it from the source, it will download it from the edge location. Also in CloudFront, also we can restrict the access, that it will only be accessible by a particular domain IP. Those restrictions we can add. Also, another advantage of using CloudFront is we can also use WAF, web application firewall, with it, which basically prevents a lot of attacks. Okay, so the first property which we have here is versioning. Okay, before versioning, let us see the S3 consistency model. S3 consistency model. Okay, so in S3, basically there are two concepts. Yeah, Dropbox also use. Yeah, also you can refer this blog, jayendrapatil.com. This guy has like, we can say, like kind of crash course kind of thing. Let's say for solutions architect. So this is also very good. Like for a quick, like before sitting, like 1 week before, you can start reading this. It has almost all the points, main points. Yeah, actually there are two consistency models in S3. One is read after write. There is actually one diagram. Yeah, read after write and eventual consistency. So when we upload a data in S3 bucket, let's say if we are uploading a file, let's say image.png, and after some time, if we again upload a file image.png by the same name, so what it will do is it will overwrite it. It will first delete the file and then upload the file by that name. Okay, so in that case, basically we will be having a data loss, right? Because S3 will overwrite the data. Okay. Whereas if in our computer, if we try to create a file, so what it does, it basically creates the file by, let's say, new file -1. Then if we are trying to create by the same name, new file -2, right? It doesn't creates the, I mean, it doesn't performs overwrite, right? It doesn't overwrites the data, right? But here in S3, when we are uploading a file, so what it does, it overwrites the data. So yeah, so first we have is read after write consistency. So what it does, puts of new objects in S3 bucket, guarantees visibility of new data to all application, and allow you to retrieve objects immediately after creation. So as soon as we upload the data in our S3 bucket, we are able to see the data. Plus, it is instantly available to be retrieved, or it is instantly available to be downloaded, right? Or to be accessed. Then we have eventual consistency. So eventual consistency is basically talking about that concept which is overwriting the data. So it overrides puts and deletes of objects in S3 bucket. It has weak consistency to archive high availability. If no additional updates are made to a given data item, all reads to the item will eventually return the same value. Okay. So here in eventually update consistency, basically they are talking about if we are uh, updating the application, updating the files or the data which we are storing inside our S3 bucket. So in that case, it will overwrite it. And read after write consistency is basically talking about data availability. Like as soon as we upload the data is accessible and we can access it, we can retrieve it. Right? So these are the two models, and in terms of the certification exam, they will not ask about it, but this is important to understand the versioning concept of S3. Okay, now as we saw that in S3, when we upload a new file, so the data will be lost, right? Now let's say if I create a file in my local machine by the same name, and if I upload it, so let's see what happens. Okay, I just created a file, empty file, using the touch command. I'm going to upload a new file. Okay, the file size is 0 bytes. Okay, earlier the file size was around 200 KB, 200 plus KB, but now it is just showing 0 KB. So what it did, it basically deleted that file, the old file by the same name, it deleted it and it uploaded this file. So here basically there is a big chance of data loss, right? Let's say by mistake, let's say if we uploaded a file by the same name, so S3 will delete that file, right? And also here it didn't ask us any warning that it will overwrite the file or it will delete the file, right? So it is recommended that in our S3 bucket we have versioning enabled. And with versioning, basically what S3 does is it basically creates the version of the file. Instead of deleting the file, it will keep a version of that file. So now let's say if we upload a new file by the same name, okay. So right now we can see it has uploaded the file, and if we click on show versions, there you can see the last version of that file. Okay, so this time it didn't deleted the file, it basically created a version of that file. So with versioning, we'll never lose our data, which we are storing in the inside the S3 bucket. And it will also prevent accidental termination accidental deletion of any data inside our S3 bucket.